Where did
A
the computer?
whole lot.
All right. So part of what I've been trying to do to get this next stage going, and part of this actually was part of the reason why I asked the survey question, what day did you work on this? So I was actually kind of curious too on that. And I was surprised to see everyone worked on it the day before it was due. Or was it Saturday? Never mind. The day before, it was Saturday, I think it was Sunday that was the biggest answer. I think it was Sunday that was the biggest answer.
It was Sunday.
It was Sunday.
Yeah.
I was planning to do it Saturday, but I was
Yeah.
completely sick and I couldn't even do it. So I was like, oh.
Which again, I'm not saying that it's wrong. I was just hoping
No.
that the majority would be earlier, because part of that is there's two big keys to this. One, the earlier you get to it, the more time after the time restriction you have to then continue trying to solve it. So I picked two very difficult questions for last week. I really wanted to put you guys with some certain topics, some certain concepts. The hash map system or bare and steady. I want to make sure you guys are getting understanding the hash maps and how those work and how that frequency systems work. There was a second half to it that I did forget. So I forgot actually how difficult it was, because the second half might be a little tricky to learn and figure out how to do it. So we're going to work through some of the logic behind it. But I will remember like, oh yeah, that was actually much harder than I thought it was. I forgot to, because I was actually looking to do it. It was just kind of like hash map centric, but it was fun. It's going to be a really good one. And I think you're going to learn a lot from it during the explanation. And the binary tree one, again, I picked that one purposely for one, trees are just good to understand, node systems. And again, that one can benefit from recursion, being able to make multiple trips. So that was the focus on that. But those were meant to be difficult so that we have a really nice review day. Today and maybe even Thursday, we'll do some review too. And I'll just assign the next Thursday challenge on Thursday. We might do one today, one on Thursday, and then give a weekend algorithm challenge. So we might actually hold class on Thursday this time. But those were purposely meant to be difficult. I picked ones that were meant to be difficult to really challenge you guys, make you guys feel challenged, so that you then have, but then of course give you something that you can then research after the time challenge. Be like, all right, here's some things I didn't understand. Let me go dig into that during the rest of the time frame, because that's what's gonna accelerate you to being hired. When you take a challenge and you fail on it, the best thing to do is to take that failure and be like, all right, well, what do I need to learn? What knowledge can I grow? Can I dig into to learn about this? I got the hash map. If you struggled with my hash map, I should go find on my own some hash map examples and some hash map challenges. How do I use those things? What are some use cases? When would I use them? So it can help you just grow that knowledge. If you struggle with the tree system, well, am I gonna go learn more about trees, which would have led you to linked lists, trees, and even one other one called tries, T-R-I-E. I think it is, right? Yeah, or tries, which these are trees with multiple branches. So the trees we've been working with are 2 branch trees, left and right, up and down. They're the binary trees. Anything that has multiple branches, more than 2, are called tries as well. They're sometimes called trees too, but there's the technical term is try. Just be aware of that. So again, part of these things are trying to introduce you to the concepts that you're like, okay, yep, I didn't get this part of it. Let me dig more into that myself. And so part of my reason for asking that was like, well, when did you realize you struggled with it? Because I actually only where I think for the bare and steady, I think the only one who reported solutions, I couldn't remember if it actually cut off the video. Evan, you reported that you actually got all the test cases on bare and steady working, but I can't remember if I saw it on the video. I thought I saw you put 1313. I'll have to double check it, but I thought.
Oh, you're thinking of the you're thinking of is a binary search tree.
That one you got fully. Okay, maybe that was it. I think the link you put in actually links to the bare and steady video though.
Oh, did I post the wrong one? Let me double check.
Probably that might have been it. Because I clicked the video and I saw it being the bare and steady. Like, oh, he solved this one perfectly. Let me watch this video. I'm like, this doesn't look like he solved it.
Oh wait, you're saying for bare and steady, I posted the is this a binary search tree one? What?
The title of the video was "Is this a binary tree?" But the video is actually of the bare and steady algorithms. Like, oh, maybe he just misnamed it.
Oh, okay.
So maybe you just selected the wrong video to upload.
Yeah, I probably did.
So, okay. Yeah, I'm not sure where if anybody. I don't think anybody actually solved the bare and steady gene. Which again, I was not too surprised about, because I was kind of one I picked because it was going to be difficult. But again, the hash map was the main focus. I wanted to see who here struggled with hash maps. If you did good on the hash maps, then the rest of it was just, again, learning different ways of approaching a problem and solving it. And for me, my biggest goal to that was just see how many different approaches did you try? How many different ways did you try to solve the problem, honestly, outside of code? How many different theories did you come up with? Did you come up with different theories? Did you come up with different concepts? And this is one that I would love, and I didn't ask about this one. This one was assigned on Monday. Which day you solved that one? Because that's one of those ones I would love to have you guys after attempting it to just connect with the classmates like, hey, what did you think of it? What did you try? So that's one of those ones that was definitely meant for you guys to discuss on it. I probably should have done the swap on that, done that one on Thursday and the first one on Monday, so you guys would have the weekend to at least chat on it in the Slack. So when you solve these, I want you to 100% feel incentivized to actually go and just chat with the class and be like, hey, well, how did you approach this? How did you solve it? Whether you succeeded or not, be like, here's what I tried and it didn't work. What, any ideas you have, anything? And again, your classmate wouldn't want to give you the actual code, but they could be like, well, here's how I approached it, which could be that clicking factor that the classmate might need to be like, oh, okay, let me try that myself. You're not telling your classmates what to do. You're telling them, well, this was my thought process. This is what I kind of looked into. You might want to look into this. This kind of helped me out a bit, and I was able to get a couple more test cases working. And by feeding off each other, you might learn something else when you want to go investigate, you want to go look into, if that makes sense. None of you guys are meant to teach each other how to do something or show each other how to do something. You're there to kind of just feed off each other and grow off each other ideas and concepts and points. So that's something I do want to also clarify too. Like during the warm-ups, for example, warm-ups, 45-minute max, you're there to just kind of go through the problem as quick as you can. Just use it as a jumping off point, bounce things off each other, code along if you need to. If the entire warm-up is actually just discussing the problem, getting you into that problem-solving state, that's fine too. So I do want to make sure I clarify that the warm-ups are just that, they're warm-ups. They don't have to be completed. That's why I don't ask you to submit your submission for the warm-up. It's just to get your brain started, give it like a rev of the engine, get it running, and so that you can then jump into the time challenge with a ready-to-go brain. So don't feel like, oh, I have to solve the first one first. Definitely, I would make, again, you definitely want to solve as many algorithms as you can. That's going to help you with the interview as best as possible. The more algorithms you solve, the better you'll be in the interview. But I do want to make sure that it's clear what the goal of these items are. The goal of the warm-up is a 45-minute, just get your mind in the zone, get your brain going, get the juices flowing, so that you can kind of jump into the time challenge with a ready mind, if that makes sense. Good, I think that's everyone that I want to get in so far, except for the ones that didn't respond. Jeremy didn't respond, Will didn't respond. Louisa's not going to make it to the end. Titus. Okay, yep, this is going to be our group for the moment. Cool. All right, so that's pretty much the main kind of just bit I want to start with. And then again, Arnell's coming in. He's going to talk about what the next stage is because I've told him what you guys have been working on. I know, again, I can understand and make sure everyone here is clear. I understand the frustration of just, it feels like it just keep pushing this finish line. But I want to make sure it's very clear. I want to make sure I make it clear. I've never promised a higher date. I've said, this is my goal. This is what I'm shooting for. Your guys' results and the code you give me can adjust that. And how much time we can put into the algorithms every day puts me into it. But what I'm looking for is with the results of these items, I'm going to be able to pick certain students to go take tests early. As soon as I see that you're consistently doing well with the algorithms, I'm going to say, hey, go attempt this outside of class. And say, I'm going to pull you aside and be like, hey, don't work on that today. Go do this instead. Let me know if you pass it or not. If you pass that, then I move on to the next, and then you're actually part of the interview thing. This is what happened in the morning group, both Margie, Michael, and now even John. That's how it went with the process. They did exactly what you guys are doing right now. I then said, hey, here's a Java test. It's timed. Give me your score when you finish it. Make sure you record it so we can review it. They get a decent enough score. Cool, you're ready. Let's move on to the interview stuff. Here's a couple more tests. Keep working on them. Here's where you didn't do well on the test. Here's what you can look into. Here's what we can look into next and make sure you get better at it. So that's what the target of these algorithms are, is that I'm hoping to be able to pull some of you out slowly little by little as I watch the improvement. As we go through these, I'll be able to kind of guide you towards what you need to learn more on. So that's kind of the main goal, and that's part of what Arnold's going to be touching base on today. So
I've got a question. The tests, the time tests, is there an IntelliSense in it at all? Or is it just
not really? No.
No. Okay.
I want to clarify, you can code in your personal ID in order to test things.
Okay.
I 100% recommend having it open and testing the code there. I would recommend then rewriting the code in the actual ID instead of copy pasting, because they do mark, hey, this code was pasted in. So HackerRank does say, hey, this code was pasted. It might be plagiarized. Just be aware of that. So I would never copy from your personal editor to the main one.
Okay.
But if you need to test, if you're fumbling with the syntax or trying to remember something, hop over to your IntelliJ, type it out, get the thing you need, and then put it over into the actual editor.
Okay.
I
all
always
right.
have a test.js file open, or just test fiddle or Java fiddle or something like that, I think it's called. Java fiddle is like a website that you can go to just type quick Java code and run it quick without having to create a
Okay.
whole Java and IntelliSense project. Because that can take some time and that can get annoying if you have multiple test files and which one's main, which one's running. So if you need to just run a couple of lines of code, Java fiddle, I do believe, has a bit of IntelliSense in it. So
Okay.
I don't know how functional it is. This is a test on. You definitely want to find your comfortable setup before you get into the time tests.
Okay.
Yeah, no, 100%. Feel free to, yes, test your code in your IntelliSense, in your IntelliJ, take advantage of the IntelliSense it has. I would just, yeah, my biggest thing, don't copy paste over because it does mark, hey, this code was pasted. We don't know where it was copied from. We just know it was pasted.
And I got another question. I was going over some algorithms, and I think it was like on Stack Overflow, and someone was like, "Oh, interviewers don't look highly upon when you use interfaces, like the built-in methods to, like, if I wanted to sort a collection."
It
As
depends
opposed to,
on
like-
the challenge. Yes, it depends
Okay.
on the exercise given. If the exercise given was for you to create a sorting method, if the challenge was for creating a sorting method and you use the built-in system, yeah, that's not good. That's going to get you frowned upon.
Yeah.
But if the goal of the challenge or the algorithm is something different completely, then using the sort method is perfectly fine.
Okay. Cool.
Because they want to see the logic for the problem, not for sorting. Because everyone's usually pretty good with sorting, but it is a common item too. So definitely take the context of the question into consideration. If the
Okay.
entire problem is about, hey, sort this data, and you use the built-in sort system, you kind of did a half-ass. You kind of cheated on me.
Yeah.
So just be with that. But yeah, if the challenge has nothing to do with sorting, but you know that sorting would make the problem easier, then that's fine using the built-in system.
Okay. Cool.
Good question. Very good question.
Huh.
Any others before we jump into the code? And I want to jump right into it so we can see if we can at least get Bear and Steady Gene done today, minimum, and then you can discuss a little bit of the other ones. Maybe some of you can even try it again. Here. This one. All right. Get out of the way. So yeah, this one was an interesting one. Go ahead.
I don't know. I was just saying, I don't know if anyone, like, with that new website we were working on with the challenges.
Code signal.
Yeah, but it's got like a very Rhode Island vibe to it, with like the gradations to the challenges, has like weathering the storm. It's like kind of nautical. It cracked me up.
Interesting. I
Yeah.
didn't notice that. I like it then. Works for me.
Look at it, dude. Yeah, I didn't know where to go after I got halfway through this and I was like, I don't know what to do next.
Yeah, I was fairly confident that the second half of this was going to challenge a bunch of you again. My goal here was to just see how many different attempts to solve it could you guys come up with. Just
Well,
trying different things.
I don't know if I got halfway. I'm gonna be honest with that. I think
Did you do the half?
it started off strong and then I hit a wall.
So did anyone here not use a hash map to count the frequencies of the letters?
Well, I didn't think about
I
the
did
hash
not.
map until about halfway through the time thing, like after like maybe 15 minutes, half an hour, I'm like, oh, wait a second, I need to use a hash map on this because I need to figure out everything. Then it took me a little while to develop the hash map and then I ran out of time. But I
Who
got that
else?
part like towards the middle.
Like someone
I
else was
didn't-
saying they.
No, I'm sorry. Go ahead.
Go ahead. No, I was like, I thought I heard someone else's voice. That was you.
Yeah, me. I didn't use a hash map either. I used collections.frequency to find the number of times that character existed, but I didn't
That could
I
work.
didn't think of using a hash
I
map.
didn't know that collections.frequency actually existed. So that can tell you how many times a certain item
Ooh,
exists.
there's an idea.
Yeah,
Exists.
yeah.
That might actually be a perfectly fine solution. As long as you're for me, the issue would be if you had to run it multiple times. So in my solution, I'm constantly having to check the frequencies against each other, and I'm adjusting frequencies for the test. You'll see that later on. So it was important for me to find a way to save the frequencies and of constantly checking the frequencies over and over again. So that would be the only thing I would say about that.
Okay, well, like I said, I got to that point of I figured out that I had to the length and all of that, and then I had to count the frequencies of the letters,
Yeah.
and then that's where I
So that's what you did out. Which again, that's kind of where I was expecting it. I was expecting people to figure out, okay, I can count the frequencies of the letters to know how many I have, because it says right here that for a gene to be steady, grab my, where's my annotation? I don't have annotation. Look at good. Ah, crud. Here we are. So a gene is represented by length of n, and that for for the gene to be steady, it must, each of the 4 letters must occur exactly n divided by 4 times. So since we have 4 characters, we're saying that each character should appear the same number of times. So that should be, if it's, if you have an item of 8 characters long, each letter should be in there twice. So 2 A's, 2 G's, 2 T's, 2 C's. We really don't care the order. Actually, we don't. We don't care about the order. We just want to know that there are the exact same number of each gene in it. Make sense? So this was kind of a hint there that we were like, okay, we may need to count them. So that was kind of the hint there. Frequencies was going to be needed. So I want to just kind of get through that part quick. So that's kind of the first straight item we can think out of the bat is like, we probably need to know how many occurrences of each gene is in the string to determine that. And that can be a quick, nice little, and honestly, if you think about it, that could be a nice base case to just kind of easily kill a program. If after counting them all, each character is equal to n divided by 4, return true. I can kill off a bunch of test cases for that right away, right then and there. The big challenge here was gonna be the second half. And that was looking at a string, what is the smallest substring that I can change to make the item steady? And so to clarify what that says is that in the example, here we go, this one right here. In the example, consider gene ACTG AAG, the substring AA just before or after G can be replaced with CT or TC. What we're saying here is that any of these 3 letters of A with my annotation tool, any 2 of these 3 can be changed to make it equal, right? That's what we're trying to say. I can pick 2 of these and change it, either CT or TC. I can pick these 2 or these 2. And either one of those can be changed to what I'm missing. If I really wanted to be legit with it, I could say that technically I can replace anything. We're saying here that I can replace the whole substring to make it steady. Of course, that's not optimal, right? If I said, oh yeah, I can change this, I can just change it to AA, TT, CC, GG, and now I know it's steady. So that's one of those things you want to keep in mind in this problem here. We're not looking for what we're changing it to. We just want to know what is the minimum, the smallest segment of characters that I can yank out and change to make it legit. I don't need to know what the characters I'm changing are and what I'm changing them to. And the best example for that, if it helps, was actually this example here. This example here really kind of showcased it because it had such a large item. Now I think they kind of, one of the things I was really interested in this one is that I feel like they might have misled some of you by telling you what to replace. By saying, oh, we can replace this with this, right? The funny thing is I could replace, if I do G, A, T, A. Yeah, I can change these 5, but no one's saying that that's the 5 I have to change. I could change these 5. Too many, didn't I? Yeah, I did. I could change these 5 right here and have the same result, right? By changing those 5, I could just turn this to a C, this to a T, and then 2 Gs, and I have what I need. And that's what that's what we're trying to keep in mind here, is that we're not looking for what we're actually changing. We're just looking for the smallest possible change. So what I'm looking for is, yeah, I want to count the frequencies. And I'm saying, well, can I determine what I can keep versus what I have to change? So is there any sort of like substring where if I put a gap around here, which is what they told us they're going to change. Well, I can say that, yeah, this and these are within the realm of a balanced item, right? The G is below the frequency and the two A's are below frequency. So if I can keep those and change everything else and get a valid item. And the way I thought about, and one thing I thought about doing was, well, if I start with the maximum thing I can change, AA, which is the whole thing. I can change the whole string. Yeah, I can change this whole thing and make it whatever I want, make it steady, right? I can change the whole thing, give it a substring of 8 and be like, I'm going to change the whole gene to a steady gene. It's a valid solution. It doesn't say I'm limited to what I can change. It says the minimum length of the substring. So you know what? I have to change the whole thing in order to get it, right? I could argue that. But that's not the best optimal solution, right? I want to keep as much of the original gene as possible. So I thought at first, well, what if I start moving these over to see when the least effect item is? Like I'm trying to think of like, what's the best I could do? If I move this here, I can be like, oh, well, I still have the 1G there. Well, that's valid. I can change all of this and get a steady gene, right? Everything I had on this side of the G, to the right, to the left, to the right of the G, I can keep this, and this is a legitimate solution still. So now my minimum is 7, right? For anyone who's concerned, again, I'm not doing the hash map yet, because this is just me playing. This is me just trying to understand how can I deduce information here. I'm not worrying about the actual code yet. I'm not worrying about storing anything. I'm just thinking like, as a human, how can I justify finding the smallest substring that I can change? That's all I'm doing right now. Does that make sense?
Yeah.
So this is one of those big things I want to clarify with a lot of these. I do a lot of non-code based, just playing with the words, trying to see if I can find some sort of logic that I can perform to solve the problem that I could then tell a computer to do. And so I force myself to try to remember what the limitations of a computer is. If I ever find an action that I want to take that I'm not sure how to make a computer do, that's when I would look that up. That's a Google search item. Like, well, I don't know how to make a computer do this specific task yet. Can I get a computer to do it? Well, let me go see if I can get a computer to do that. I know that this step is something I need to do. Can I get a computer to do that? Can I get my code to tell a computer how to do that? So far, I'm not doing anything crazy. So move it over, that's legit. And from here, I could go I could do whatever I want. I could, again, move this one over. I could try moving this one over. I really don't care. There's no real statement of which one I have to move. So maybe I'll move the right side now. So I pull an 8 in. Again, I only have 1G and 1A. That's below the frequency of this one, which is 2. I need 2 of each, no more. So I could change this whole 6 string and it would be valid. So there's another smaller string I could change. I could change this into exactly what I want. G, C, C, T, T, A. I can do that. So we go back to the left side now. I'll move that one in 1. Bring in another A. Potential. Blue. How's that look good? So I have A, G, C. I have 2 A's, A here, a C here. I have 5 characters. And again, if I'm looking at this, well, this is underneath the frequency. This isn't, this isn't, this isn't. These are all under the frequency, so I could adjust this to whatever I need it to be again. I can do another G, T, C, C, right? So I could adjust this to what I want it to be. Just for the sake of argument, let's move this over again. I need to also find a way to know that I've hit my minimum. I need to know a way to find out, did I hit my minimum, right? Or can I keep going smaller? So let's try the right side again. Hey, Alita made it early, nice. Hey, Alita, made it early, nice.
Yeah.
I don't know if you just have to try to see if you can catch in on what we're looking through, but we are recording it, so you'll be catch the beginning later.
Perfect.
But again, I'm going to move this over. And I'm going to check and say, okay, well, let's see, that brings our A to a 3. there's a problem here though, isn't there? Without knowing the frequency of this substring here, I can tell that this gene, whatever these are, plus X plus T, I'm sorry, we do plus AX, the count of other A's that I don't know, plus the count of GX, we'll do GX, which is how many other G's there are, plus TX plus CX. So let's say that there is I'm going to do this just for the fun of it, just to illustrate what I'm thinking in my head. That's a highlight. That's not what I wanted. Undo. Actually, that kind of works, actually. Screw it, we'll do that. Imagine there's a panel over these 4 characters here. We don't know what those 4 characters are. So I'm saying that in that empty space of the other characters, we know that we have an 8-character string. So we know that our frequency, as we said here, was 2. Each character should only appear twice. Move that over there so it's out of the way of the counters. So we know that technically I'm visualizing a GAAA, GAXY blank 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 AA. So I have 3 A's, 1 plus an unknown number of A's here. I have 1 G plus an unknown number of G's, T, which is 0 plus an unknown number of T's, and C is 0 plus an unknown number of C's, right? I have unknown items here. But can I already tell this gene is non-steady? Can I already make that deduction?
Yes,
Why?
because there's too many A's.
Exactly, 100%. I have 1 too many A's already. So I don't need to know what's in the substring. I already know that the genetic code as I have it is already invalid. I can't modify this in any way to make the rest work because I already have too many A's. So, well, maybe this was a T though. So if this was a T, then I could actually do more on the left side. So I don't know for sure, but I do know I can't go this way anymore. So I'm going to backtrack it, bring this back over here. Make my blocked panel a little bigger. And move the left side again. Note though that I didn't change my substring. My substring stayed at 5 because I could take that 4 substring. That didn't work. Ace goes back to 2 for a second, and then I move my block over again, and now I'm blocking those 4, and I've exposed another A on the left-hand side. And again, if we do our numbers again, we know that that gives us 3 A's, and we know again, can't do that, right? That's a substring I can't take. I've already made my gene imbalanced. It's unsteady anymore. And so this seems to be like, maybe this might work, right? I've at least figured out a way to say, to find that minimum string, and we can test it again with the other example above. Make sure this concept works. So we'll clear that out again. And we'll do this guy. So we want to confirm that using our same logic, we can end up with a substring of 2. So A, C, T, there, undo, T, G, A, G. Start my counters. A, 0, and again, we're going to start everything at 0. C, 0, T, 0, G, 0. Now, what I will argue is the first thing I could do, of course, is scan this to see if it's already stable. So I would want to clarify that. It's probably a good thing to do. If I was to pre-count it, I could easily and quickly just say, oh, already steady genes. I want to find a way that I can already clear them. So maybe I want to be able to track them, but again, we'll touch base on that in a second. I want to know if my moving window, my closing window system works. I want to know if that works first. Being able to pre-approve already steady genes, I'll look at that later. I'll see if there's a way I can switch my solution up to include that later. I just want to know if I'm on the right path still. It seemed to work in the previous example. I want to see if it works in this example. So start with a bracket on each side, and I am,
Listen, I'm just gonna be honest. I'm kind of lost on the logic here. Like, how are you gonna figure out which ones you should be able to change? Because they
Yeah,
are
substring is
determined to
a-
show-
maybe I forgot to mention that. So a substring is a set of concurrent characters. They have to be in a row.
Yeah, no, I get that. But what I'm saying is like, if you scroll down to the bottom at the sample input and output.
Yeah.
Because maybe I'm just like lost here. All right, so that's the sample input, right? So they decided that AAATA was what they wanted to change. Why?
That's what they said you could change, not that they are changing. They said you can change that one. I did clarify that we don't need to send that. We just need to send the 5, and I showcased that technically we could also change these 5 too, right?
Yeah, it says right there,
one
one
optimal
optimal solution. So that means there's more than one solution, but optimal would be
Yep.
that one.
Well, I understand that. That's not what
Yeah.
that's not my problem. My problem is how did they select the letters that needed to be changed?
For them, they're doing that because they don't want to give you the actual way of solving it. They're just showing you that this is one optimal solution. So they just selected a optimal solution of 5 characters long. They knew that the minimum substring was 5 characters, so they just picked an arbitrary 5 characters that they could change. They technically picked the first 5. That's all they did. They picked the
Okay.
first 5 characters that they could they could legitimately change. It just showed you, oh, this is why the reason why it's 5 are optimal is because, well, this is one of the examples of 5 characters that can change, resulting in a steady item. And even this order here, like this doesn't even matter too, because I could technically make it stable by doing T, G, C, T, G, and that would make it valid too. That would make this stable as well. So I think that's one of the slight misleading things that this didn't clarify enough for people, and that's why it helps to read it a couple times and make sure you're understanding. Is that no way are we actually caring what the actual, as a developer, we don't care what the characters are for the result. We don't care what 5 characters or what characters they are changing and what they're changing them to. All we care about is that we can change a certain substring to make it steady. That's all we're trying to do. We know that in this system, we can change 5 characters between this area here, any of these 5 characters, G, keep the G there, and I can make it steady. And what I argued and tried to explain, maybe I didn't explain it enough, is that what I'm showcasing here is that currently the example I gave here, which is the one above, I'm saying that the minimum substring that I could make this steady is 8. If I had the ability to change all 8 characters, I could make this steady, right?
Yeah.
Is that true, David? If I changed all 8 characters, I could make this steady, right?
If you change all 8 of them, you can make it whatever you want.
Exactly. But that's my, again, I'm trying to keep the logic simple and stupid to
Yeah.
make it understandable. It's legit. It's a legitimate statement. It's a legitimate logical statement. I can change the entire string, and that's currently my minimum. That's my minimum currently, 8. What I need to do is then I want to reduce this to find a smaller string of a possible fix, right? What's the smallest substring that I can find that allows me to change it? And what I know is that in order for it to be stable, I need to have all the characters be
And divided by 4.
the frequency. And this
So
one's
yeah, you can only have 2 of each.
Yep.
So-
And so what I'm wondering is that what I decided to test is if I start bringing others in. So again, I'll do it here. This is why I want to do it again to make sure it's clear. Saying is, okay, well, let me move this one over and I'm going to bring the A in as part of my count. So A is now 1. And I'm saying that I'm going to be able to modify all of these characters to make it steady. Can I do that and have it be steady? Well, how I can justify that I can make it steady is that are all my current frequencies below the required frequency, right? Because then I can just change these. So right now I'm doing 1 plus the count of A's in the hidden area. I'm just going to call Y. The hidden area is Y. The C, I have 0 C's plus an unknown number of C's in the hidden area. There's an unknown number of T's in the hidden area. There's an unknown number of G's in the hidden area. So I don't know what's in here, but if I take this, I can make the hidden area whatever I want. So I know that I have 7 items in the hidden area. I could put an extra A, 2 C's, 2 T's, and 2 G's, right? So I can legitimately change all this to whatever I want, can't I?
Mhm.
So that's the smaller substring, 7. And what I'm testing is, are my current frequencies below the frequency I want, or that I'm limited by? And I can again redo this one again at the end to make sure this one makes sense too. So we'll do that. We will do this one to make sure I clarify again. So looking at this, I bring the A in. A is 1. I check it. Are all my frequencies less than 2? Yes. This is A. I could change all this to make a steady G. Cool. I have a smaller substrate. I don't need to change all 8. I could just change 7 of them and get what I want. My current theory is to go from the left and then the right, and then left, right, moving each one on the side. I might change that when I go to the code. For the time being, to help my logic, to help me think, I'm going left, right, moving, squeezing in from the outsides in. I might change that when I go to the code, but for now, this is working for me. So let's try it again. I'm gonna move this one over 1. So we reveal another character. We reveal another character. Oops, I did too many. Everything inside the brackets is my Y. This is my Y. This is the hidden space. And if I want to make sure it's clear what's going on, I'm going to do this quick just for a second. I don't want to do this every single time, but imagine there's like oh, you know, actually, screw see-through because I have the undo button. Imagine it's like this. I'm not actually going to leave it. I'm going to get rid of this in a second, but imagine that's what I'm seeing here. I don't know what's in there. All I know is that I have an 8-character string, so I know that there's 6 more characters in here. I'm going to undo that because I don't want to ruin that. So now that I've revealed the G, I add 1 to my G. I still have the yellow. We switch back to blue because that's hard to see. Again, if I look at these again, if I compare to my thing, this is within the realm of, I can make this steady. I know I have 1A plus an unknown number of A's, C, 0 plus an unknown number of C's, 0 T's plus an unknown number of T's, and you have 1 G plus a number of G's. I know that whatever's inside this Y, I can make that what I need it to be in order to make it work, right? I can change that to whatever I need it to be in order to get what I need. So that's a valid substring again. So now I've gone from 7 to 6 as my smallest substring. So far, so good?
Yep.
All right, let's try it again. We're going to go from the left side now. I'm going to again move the left side. Move that over. I now have added a C to my count. And 1 there. I now have a substring of 5. Are all my frequencies below the frequency limit?
Yes.
So again, I can change all 5 of these to whatever I need them to be in order to fit. So my now minimum substring is 5. I'm working my way down. I'm getting close to what we know is the requirement, which we know that in basically the example above, we're trying to get 2 as our minimum substring. We were told that changing the 2 A's, either one of these 2 A's was going to do it. So let's move another A. Let's move the bracket over again. We reveal another A, so now I have another guaranteed A. Let's look again. Are all my items less than or equal to my frequency? Because again, I can have an unknown number of A's. So I can have, this could be 0, right? I can make sure there's no A's in the substring, right? If there's any A's in here, I can remove them and make them whatever I want. So this is still a valid item, right?
Yes.
I can remove the 2 A's and change them to the 3 items I'm missing here. I have the T, I can make sure that there's 2 T's and 1 G and 2 C's. Because I have, I'm sorry, the other way around. 1 C, 2 T's, and 1 G. I can do that. I can adjust the insight here to whatever I need it to be to make it steady still. So new substring 4. I can have a substring minimum of 4. Back to the left side. Move that over 1. Reveal the T. We're going to add 1 to our T. I should erase the 0. At it. Same question again. Are all of our frequencies under the target frequency? or equal to.
Yes.
Again, I can change these three here to whatever I need to make this match. I can keep the G a G and change the two A's. Again, now my code doesn't need to see this. My code doesn't know that that's what's here. Or the computer, for example. Again, if I'm acting like a computer, I haven't viewed these yet. I haven't looked at them yet. So as a computer, I don't know what they are, but I can also confirm the leap of logic I'm making by looking. It's like, all right, I'm assuming I can change it through. If I look, yeah, I can. And that I can make this legitimate. So that's one of the benefits of doing this whiteboarding exercise, that I can also say, you know what, for a quick second, let me not act like a computer and confirm that my computer steps that I'm following, or these strict steps that I'm following, do work. And like, okay, yeah, I can quickly change these to what I need them to be. Cool, so this is still making sense. So there's my 3, new substring. Let's try again. We're gonna move to the left one. We've revealed an A, so we add A to our counter. How's our frequencies? Are they legit?
No.
No, that's gonna break it, right? We now have too many 3s, and it means I can't change these 2 inner ones to make them stable in any way. I have too many A's. I can't do that. So I'm gonna backtrack, undo that, rehide that A, make sure that that A goes back down to 2. And instead I'm gonna move the left-hand side. And I could now, thinking ahead, if I'm thinking of code, I can make a note to myself like, oh, as soon as I invalidate one of the 2 sides, I no longer want to modify that side anymore. That side should be locked. Because now I know that if I ever move this side anymore, I'm always going to be invalid. So now I just need to move this side until it no longer works, right? Now I just need to move the left side until it no longer works. I don't need to move the right anymore. So let's move that item over. I see another G. So increase our G to 2. Let me go ahead and clean that up, make it a little nicer to see. Oop, wrong button. Yeah. Looking at our frequencies, are they valid?
Yes.
Good. I can change the 2 inner A's to whatever I need. So there's my next substring, my 2. Again, we already know that if I move the right side, it's not going to work. And to save me from having to draw it, if I move the left side, we know we're going to increase the A. That's going to invalidate it, right?
Right.
So look at that. We got the 2 we wanted based on the example that was given. We were told that 2 is our smallest substring, and we got that. 2 A's. We want to see this one again, going through this process again, just to make sure that the first example makes sense again.
So
Yes? All right.
just a question.
Go for it.
Like this one here and the other one, I realized they both have more A's, but I realized that any test case could be more G's, more T's, or whatever. But can't you just
Hey,
take?
if you want to give us an example, go for it.
No, I'm just saying. What I'm asking is, we know how many A's we know how many A's we got. So can I just balance out? Like we have 1 G and 1 T. We need at least to have 2 in each, so we start distributing
Ah.
the A's into other letters.
That was one thing I wanted to save a little time, but I was wondering if I should discuss some of the initial theories that some people came up with. So one of them was, yeah, if I count them all. So in this example here, well, I have 1 G, 6 A's, 1 T, and I have 0 C's. Could I just notice that I have an extra 4 A's, so couldn't I just say my substring is 4? Well, I don't have a series of 4 A's in a row that I can change, can I?
No, but I would say that
No.
you have 6, but I could start taking 1 away and add it to each of the other letters until they all balance.
That's again, that's where the trick comes into play. Yeah, I could just, so I could take an A and add it to G, and then add another one to G, and then add 1 to T, and then add 1 here, and then add 1 here. But again, that only gives me the 4, right? I need to find a substring of concurrent letters to change. That's where that one doesn't work. I knew that everyone was going to at least think of that initially, and that's a great first initial thought. But yeah, that's where testing your theory considers it. Like, all right, well, yeah, 4 is the substring, but look, this says this has to be a 5. How can I get 5 out of these numbers? Right? The problem is I technically have to include the 1T as part of the substring I need to change. I don't necessarily have to change the T, even though they did. So in their example, they took the T and moved it to the beginning for some reason. Not necessary. They could have kept the T where it was, but they do need to include the T in the substring. I do need 4 A's to change, but since I don't have 4 in a row, I have to include at least whatever's in between to make sure I can get a 4 A's.
So where does it say it has to be in a row?
Substring. The term substring is
Okay,
is a series of concurrent letters. I think
all right.
it explains that. Doesn't explain what the substring is. I think it does.
One character, right? Or does it have to be consecutive to be a substring?
So a substring to replace.
Large substring.
Yeah, it says a substring of string S is a subsequence made up of 0 or more contiguous characters of S.
Where does it say that?
The note. I'll go back up.
Where? Oh, here it is. There it is. Okay, good. I knew it said it somewhere. A substring is a string of a
Okay,
string is a subsequence made up of 0 or more contiguous, this is the key word there, characters of S. So yeah, it has to be characters in a row. If this wasn't there, then yeah, we could just do what you did here and say, oh, I just need to change 4 characters to make it steady. Yeah, if we could just splice individual genes and just switch random ones, then yeah, then your item would just be to count them up, find the largest one or find all the frequencies that are above the limit frequency and then bring them down, and the difference would be the total. Not a wrong path, just not right for this problem.
Or if they're less than n divided by 4, you would add them. But yeah, I tried that approach and yeah, that didn't work.
I saw you do that, yeah. I saw that in yours. Like, nope, I was expecting that. It's a good start. It's a good initial theory. 100% a good initial theory, and is what I did first too, to check, and then I noticed it was wrong because of this. This is why, again, testing your theory is key. By testing it like this, I was able to notice that this didn't match the example given. Like, well, that's not right. The substring's not 4, it's 5. Well, how do I find this stupid guy? It's like, this T is my pain in my ass right now. How do I find that T? He's ruining this for me. So that's where I had to come up with a different system. And that's where I was like, you know what? I need to think more broadly. And that's why I came up with that concept of like, well, let me start by saying I can change the whole string. That is a substring. A string of a string can be the whole substring. Sorry, other way around. The substring of a string can be the whole string. That is technically allowed. So I said, starting from that basis, can I bring the outsides, in and just change the inside? How can I justify that through logical deductive reasoning? And that's where this one can be a little difficult. This was a little more challenging because it's relying a little bit on deductive reasoning. And like we said before, that's where some of those logic puzzles can help you to grow your deductive reasoning. And working on these and then discussing them with your classmates can help. And part of it, I just want to showcase this idea of deductive reasoning, trying multiple different attempts. I didn't want to show them all because we're limited on time, because I know I was jumping in at 8:30, but I wanted to show a couple examples, the kind of how I can work through a possible solution and come to it. And part of that is based on creating very generalized logical statements. And like I said, in this one, if we do this one example one more time, just to make sure it makes sense. G, A, T, A. Again, if I make that generalized statement that the entire string can be changed, well, then I'm good. I have a starting substring of 8. I can turn that in. I want to find a smaller one. So let me start bringing in characters to see if I bring this character in, can I still adjust the rest to make it legit? And so, like I said in the beginning, I didn't even include this. I just said, well, yeah, I can do the whole thing, but I can also keep I may have done it like this in the beginning when I first did it on my whiteboards. I might have just been like, oh, well, can I keep the G? Yeah. Can I keep the A? Yeah. Can I keep the other A? Yeah. Can't keep that one. Can I keep this one? No. Oh, there's my 5. I think that's the very first example I did of it. I did it very quick and kind of messy, and this wouldn't have been a good way of showcasing it to you guys, I thought. I was like, okay, that's a good start. And that's when I started. And then once I do that way, I do this really rough and dirty style of just kind of like throwing lines around. I then clean it up and do it a little nicer for myself to make sure I understand my thought process. And I start using things that I recognize as part of code, like array brackets and stuff like that. Because then I can think of, oh, I can use indexes to iterate through left and right. I can have like I at 0 and J at the length, for example, representing these kind of brackets, right? That makes sense a little bit?
Mhm.
Good. Sorry, let's show this
Sliding
works again.
approach,
So,
that's an approach I think they call a sliding window, right?
right, yes, I
Where
do
you
remember
move
that. After I solved this myself, I looked into some of the examples and people called it a sliding window. Yep.
Because
I
as
did
you-
more of a reducing window. The sliding window would actually be, and I actually realized after I solved it, I'm not going to code it this way because I don't like the solution going left and right because the code for that's a little annoying. I need to create like flags. I didn't like having to create flags to say, oh, if left or right is done already. So how we noticed like, oh, if I keep moving, I've already noticed that the left side is, or the right side was done. And the one in the above example, I couldn't move the right side anymore. I had to create like a Boolean flag to make sure I stopped moving the right side and only moved the left. So I ended up not liking, I didn't really like the solution. So after I solved it, I did find a way to improve my solution. But I did use this moving in from the left and moving in from the right in order to solve it. And then I looked at other people's solutions to help me kind of optimize my solution a little better, to make it nicer, and learned other ways of implementing a moving window system. So, which I will be showcasing that. Again, to follow the same logic again, we have this one. Again, we'll move it over. We're going to bring our G in. So we have 1G. Our frequencies are valid, and I'm going to go through the first part kind of nice and quick. So we have a substring now of 7. Again, I can modify everything in here to make it work. I move the right side over now. We'll bring our A in. And as far as I'm concerned, I think it's a safe logical assumption that I can make that the maximal minimum is going to be n minus 2, right? No matter what, if I had GG and then the next one, both these are G, then my maximum would be that, right? If I had an array, if I had a string like GG something, 4 other characters, and then GG here, I would invalidate both of these, but there's no way I can not do a substring of less than 2, right? That's kind of like the maximum smallest thing I could change, because the outside, I can always bring in the 2 outsides as like the worst case scenario. So by this time I now realize that, but I realize that probably doesn't help me, right? Maybe if I wanted to, I could save 2 iterations by just pulling the 2 left items, the 2 last digits in automatically, but I'm like, yeah, that's cool. But again, that's where you can see that there's additional logic you can pull, but not all of it's going to be useful. Yeah, I could use this, but it doesn't really matter. So be aware that you can make those realizations and realize, I don't really care. Yeah. A. This is still valid. We have 1A, 1G, so all of these can be changed to make it valid. So now we have a substring of 6. I'm going to bring in another A on the left-hand side. We increment our A to 2. That marks our 6 to 5. So that's all valid now. Because again, we can see 2, 0, 0, 1, all less than our frequency, which again is 2 in this case because 8 divided by 2. We attempt to bring our right one over and notice that this will make it wrong because A will hit 3. So that's going to be bad. So we then backtrack it. And like I said, well, now I can make sure I mark something in the system, say, don't look at the right side again anymore. We don't want to touch that right side anymore. Always going to bring in an A. So we're not going to be able to use that side anymore. So instead, we'll move this side over. Notice we bring in A again, puts us out of it. And again. So now that we have both sides as not able to be pushed in, we see that our smallest substring is our 5, which again does validate to the example. Now let's say again, you're not confident in this. Let's say you're still not confident in this. You are more than allowed to hit the run code button as long as you can get it to run. So you know what? I think Lita did this once, and this is like I tend to do too. I just make this happy.
Yep, that's what I do.
Just so that I can run the code, because now I can get, I see these 2, these are the example, this is an example case they gave me. So I could, of course, if I really wanted to try this one, if I really wanted to, if I had the time, I'm like, you know what, if I did not feel confident, I could go ahead and bring this one in. This is going to be a while because we're going to break down a 40 into a 5. So you know what, I'm going to submit it. How many of these are unlocked?
You
Any
got
of them
one.
unlocked. It's the same two. All right, sometimes you get lucky and I'll give you another one that's unlocked. But in this case, again, I could do this one or I could even come up with my own now. And so that can be a really useful one, coming up with your own. And so now you can ask yourself, well, what are some of the situations where I feel like maybe this wouldn't work? Are there any, this seems to work. It makes sense to me, but is there something that can like, well, in this case, would it not work? In this situation, would it not work? Does anyone have an idea like that?
Well, I could say
situation
if
where
they were all A's.
All A's, if you want to do a different character, it's
Well, if you
constantly
do all
doing A's.
A's, then you could just change anyone that you want anyways, anyhow, so it would be 8.
But again, what would the minimum substring be that we could change? Let's do it quick. We'll do all A's. We'll do, or let's do a different letter because we keep doing the A's. Let's do all T's. 1, 2, 3, 4, 5, 6, 7, 8. And we start with everything marked off. We're at all 0. Our frequency limit is 2 still. We'll bring in one of the T's. Now, that I can change all that to make it valid, right?
Yeah.
T, C, C, G, G, A, A. Good. So we have a 7 substring now. So the 8 was invalidated. We don't need to do the 8. We can do the 7. Bring the T in over here. So that brings our T to 2 now. That's still valid, right? I can change all these, right? And make it valid, right? Well, now we know if I bring this side in, that's going to invalidate it, right? I'm going to have 3 T's. Can't do that. And if I do it on the other side, same thing. I have too many T's. So this would be the minimum. The 6 would be the minimum substring in this case.
Okay,
I
so
would
if
have
you only
no
had
matter
3,
what.
if you only had 3 letters then.
Well, no, 6 letters I have to change. I have to change 6 letters in order to make this work because I can only keep
Right.
2 of the T's. Now, I can only keep this T and this T. I could keep those 2 T's. I could, and then change. Let me do this quick so it makes sense. Hold on. Button. Here we go. And I would change these 6 right here. I could. This is where, again, doing this is just going to help you with your logical understanding. Why did I do the yellow? I'm going to make these the same. So these 6 being changed in order to keep these 2 T's with the blue arrows. If I change to orange, I could keep these 2 T's and change these 6, right?
Mm.
Or I can keep these 2 T's and change these 6, right? So that's one of those things I'm going to keep in mind. Now I can't do it in the middle ones because I can't change 2 substrings. I have to be consistent characters. So I can't keep 2 T's in the middle. It's going to be the 2 T's on the edge, or the 2 T's in front, or the 2 T's in the back. So again, the substring I'm changing has to be consistent. Make sense? And again, this is where doing stuff like this can really help to make sure you're understanding your logic, understanding your understanding, and it's making sense why your logic or your approach might work. That sound good? So the next thing I want to look at, and how I was able to justify the change of
3 G's.
what's that?
Well, that's when you only had like 3 and you were under 4. You only had 3.
Give me a string then.
Like TCA.
Well, first off, that's not allowed.
So that would be, well, okay, so the minimum constraint is 4, so you have to have at least 4, I guess. So you could
That's
actually,
you.
Excuse me.
Let's see.
God dang it, I'm gonna do that later.
okay, constraints
Start
is
here,
4, like less than, it can't be less than
And
4.
the length of the string is always going to be divisible by 4.
Hmm.
So we don't have to worry about getting anything that's not divisible by 4. All of the inputs, there's a validator that's already confirming that the gene string we're getting is divisible by 4.
Okay, so if you put a G at the end of that, TCAG, that would be right because there'll always be 1. So that should be a valid one in the
That's the
first place.
frequency. Yep. n divided by 2, which is going to be, sorry, n divided by 4, which would be 4 divided by 4, which is 1. There's our frequency.
Yep.
If we count those up,
Yeah.
all good. And we can even test this on the smaller case just to make sure that our logic made sense. If I change this C to a G, so the fun of it, brackets, we bring in the T, we have 1 T, that's valid. We bring in this G, we have 1 G, that's valid. We bring the G in, now we have 2 Gs, that's not valid. So we put the G back in the hiding spot. That up a little bit, PG, AG. AG. And our brackets here. Here right now. Well, let's bring the A in, T something AG, that's allowed, right? Oop, dang it. And because now here's a good thing here. It's like, oh, well, now I don't know how to stop this from bringing this G in. But if I was to bring the G in, if I moved it over, I would invalidate it again and showcase that I can't include that. So my substring would be 1. So if I did move this over and I got them to my 2 lines to crisscross, I could check for that to see if I included all the characters. And because at this point, if it was valid, I would have already, I should already notice it. This would also be a way to say, well, you know what? I could do this and would make sure it is valid. If I do get all characters included and I don't go over my frequencies and they touch in the middle, I can mark that as, oh, good, we're good. This string is valid, but I feel bad if I have to go through this whole process to confirm something's already good, right? That doesn't seem good to do, right? There should be a way for me to be able to determine if the string is valid before that goes. So I'm going to do a quick little test. Let's bring in our big one again. So G, A, T, A. I'm going to try doing it this way, where instead of going the whole string, I'm going to say, you know what? Let's start in this case, where I do A has 6, T has 1, G has 1, C has 0. I'm going to say, you know what? If they're not matched, I'm going to start from this side, start boxing out items one by one until I find that I'm currently good. Let's see if that's going to work. Instead of doing a reducing window, let's do what actually Evan mentioned, which is a sliding window. I'm going to slowly make a window that goes bigger and then shrink it as well after I make it maximize. It'll make sense in a second. Let's move one side over as much as I can until I can't move it anymore, and then move this side over until it doesn't work. See if I can do that. So we're going to move it over one. We're going to look. So if I have, let's do this. I want to use a pointer instead now. So I have one pointer here pointing at the one I'm moving, my left and my right. So pointing at G, I'm going to take the G out of my system. So I'm taking G out, G is at 0. Is this a valid item yet?
No.
No, we still have too many 6s. So let's move let's increment our I, or 1, I by 1. We move over to A and we count. Now we're going to count A and say, okay, well, we're not balanced, so let's remove this guy from it. Remove it. We have a substring of 2 right now, but it doesn't work. Well, actually, yeah, no, it doesn't work yet. So we don't have a substring yet. A. So we move that. Is it balanced? Or do we have a decent system yet?
No.
No.
No. So let's move it again. Move it again. We'll cut out that means our I is now at 2, 0. So nope, not good yet. So we're gonna move that down to 4 now. So now we have 4. Is that good yet?
Nope.
All right, move it over again. Our I is now at 3. Again, we're gonna reduce that guy now, and now we're down to 3 A's. Is that good yet?
No.
No.
Nope. All right, let's move again. So far, like, this doesn't look promising, but you know, it's good. Let's keep going with it. We're now at I4. We're going to remove the T. Well, this is looking weird. Now we have 0, 0, 0, and 3. Still not good, is it?
No.
No. So let's try again. Move to 5. Move another A. All right. Now we're within the realm, right? We are at least within the realm of saying, well, these are all of these items I can change, and I have a valid item, right?
Yep.
So I take 5 minus 0, say, okay, my substring is 5. I could change these 5 characters and make it balanced, right?
Yep.
But that's probably not, I'm sorry, not 5. That is 6, right? Oh yeah, sorry. So here's something to keep in mind. I probably, before checking to see if this is valid, I should probably increment my I and look at this, and before I remove it, decide if we're valid or not. So I move this over and say 6 minus 0. That gives me the actual substring of these guys that have been removed. That makes sense? So I should probably increment I before I check to see if we're balanced. Okay, so increment I, I'm pointing at this guy. We are balanced. Okay, so we have a valid item with the unknowns. Since we remove these from my count, these are all unknowns now. That's what we're technically doing. So I can do 6 minus 0, get my substring, which is 6. So that does match the number of characters here. But I now don't know if we're actually equal right yet, if that's the best I can do. We do know, because this is an example, we know that our best is 5. So this logic doesn't work yet. So now let's try moving this guy. Now that we're balanced currently, instead of removing this guy, let's move the left side now to see if I can bring certain characters back. So let's bring back the G. I'm gonna count. I'm gonna bring back the G. So that goes to 1. We're going to increment our J now.
I guess from here you can move move J into and see if it's still
So move
valid.
J. We're going to
With
check to
one
see if we're
there.
still balanced. So now we have 2, 0, 1, 0. Are we considered balanced? Or at least valid?
Yeah.
Yeah, so we're valid. So now we can do again, since we are valid, we're not going to remove this guy. And we're not going to move this yet until we get the substring, because now we've confirmed that this is a valid substring. So 6 minus 1 gives us 5. But again, we don't know if this is legit yet, right? We're not sure if this is the smallest. As humans, we can look and be like, yeah, no, I know this is what we want. That's the number we wanted. That's it. But again, we want to go through our logic. We want to go through a computer logic. The computer doesn't know that this is legit. It can't see these characters that I have here, and it doesn't know the output. So always remember that when going through your own personal examples, keep going, because that's what the computer would do. The computer right now doesn't know it's the best option. So we're going to keep going. So balance, we're going to move our left one again. We're going to move over to A. I'm going to bring this A back in. So now we go back up to 3. Our J is now at 2. Is this a valid substring now?
No.
No, it's not. So we don't update our substring. We don't update this, but we instead move I. So let's remove this A. 2. We increment our I. 7. Are we balanced? Are we valid?
Yeah.
We are valid. So we do 7 minus 2. Well, that gives us 5 still, right?
Yeah.
So we're still there. We're still at our 5. So, all right, let's move this guy over. Back to 3. Is this valid?
No.
Nope. So we don't take the 4 substring, and we can't move over I anymore, can we? I is at length.
Mhm.
So we're done, right? We can't move I. We already know we invalidated with our other side, so we would have to try to move this. It's not going to work, is it?
No.
No.
This logic seems like it might work, doesn't it? It did look promising at first, did it? It looked scary at first, didn't it? So we removed both the D and G. We started removing all this and like, oh God. It didn't look good at first, but that's why it's good to continue through your logic and continue through your thought process to try to see what you can come up with. And that's a key item of computer science. Trial and error, testing things out, trying different approaches, and just really, of course, also just taking the first one that seems to work. So if you've already spent a good amount of time coming up with that reducing window system with the left and the right sides go in, build that. That's something to build. If you realize, you know what, let's say, I think I give you guys 60 minutes on this. Let's say you spent like 20 minutes on it, 20, 25 minutes coming up with this thing. You know what, let me give myself 10 more minutes to see if I can come up with something like this. If I don't, I'll create this. Let me give myself 10 more minutes to see if I can make this a little nicer. Because with this system, since I pre-count everything already, I can confirm if something's valid or not right away, can't I?
Yeah.
Because I counted all the indexes at the beginning, if I was to get one of these two guys here, not this one, sorry, one of these guys up here. Fun. I don't need this anymore. Clear that out. If I get one of these two, the GACT or the AAGCT one, I can use this pre-counting system to pre-validate, right? I can already confirm that this is good because I've already counted all the frequencies. I can test that all the frequencies are 2, right?
Hmm.
So there's some things to keep in mind. Let's code this. I want to code it now because we're running out of time. Can I code it in 15 minutes? Let's find out. Again, to get it quick and kind of walk it through again, we know we have an I and a J. We need to keep track of our smallest substring. So we probably have something called min that keeps track of the smallest substring, which we can probably start at the length of the string, right? So we make that equal to n. I and j would start at 0. We have our, what do they call it? What do we want to call this n divided by 2 thing? Our frequency, our factor, our limit, what do we want to call it? Lane's muted.
This always stumps me. Like, I don't know what to call things. I'll be like this and I'll be like, what am I gonna call this? And I sometimes give them nicknames.
So here's the key thing here. The key thing for naming something is that it should make sense for you if you were to come back to it later, or what is it storing? Really, if I was to refer to this in my examples, what have I referred to this before? Whenever I had to talk about this value, what phrases have I used to reference it?
You called it the,
There are a couple phrases I used.
and I wrote it down. You called it the, shoot.
I'll remind you until we have a little bit of time. I call it like frequency limit,
Yeah.
limit.
The
a
limit
factor.
or oh, you called it something I liked a lot.
No.
I also use what it says right here, a letter occurrences, so you can use like occurrences.
We could call it
Occurrence.
occurrence if we wanted.
Or
We
the,
could call it occurrence. But is that a fun word to use?
well, you're gonna read that one later. That's my big problem. I think, well, what can I call this? And I don't know.
So those are your rules. What have you called it during your examples, especially if you were trying to describe it to someone? What have you used to help you understand it? It's like factor, limit, frequency, occurrence. Those 4 terms would be the ones I would pick from. And the second thing I keep in mind is what's easier to type too. So those are my 2 rules that I used. What would I actually call it if I was explaining this? And what is something that I would be okay with typing? I don't think I would like typing occurrence personally.
No, you can
Can't
just do
remember how to
O, F,
spell it.
it's just O, F, and
I'm gonna go at least. So here's the 2 options I'm thinking of. I would go with frequency or FREQ because that's a common abbreviation for frequency.
mhm.
Or like
I
ratio,
would-
maybe?
We could do ratio. That would be a click, or again, our limit, because we are using it as like how many maximum we're allowed to have for each character. So those are the 3 words I would probably range from: frequency, ratio, or limit. Those would be I would use one of those 3. The frequency of the letter, it's the maximum frequency. Limit, because I've referred to it as a frequency limit or an occurrence limit, or ratio because it is a ratio, n divided by 4. So quick, let's pull up the chat. I'm doing a poll. I think we lost, Richie stepped away, and I think we lost Christian a while back. Yeah,
Yeah, Christian left a while back.
I think he had to head out. Someone came up. It's this. Oh, fine, you guys can see this. That works though. Don't use the pen. N divided by 4. We'll do frequency. We'll do
Freaky.
ratio.
I want to do freaky.
You can say that.
Oh, wow, wow.
You can store that one. I'm gonna stick with
Yeah.
freak. Keep it professional in case I ever have to show anybody this code.
Yeah, keep it profesh on the interview, all right?
I'm gonna get some other ones. We'll do max, or even we can go max freak. There you go. That'll be the fun one. I'm gonna regret this one. I feel like. Anyway,
Super freak.
that doesn't make sense. Super freak doesn't make sense. Max freak. Max freak at least stands for max frequency.
I think
Yeah,
I might,
that's the
if it was
whole-
me, I'd probably go for super freak.
Good to know.
The Rick James of coding, all right.
I smell a skunk.
Oh, that sucks. Try to get this going quick, people. I don't know if Richie's back, so I will exclude him from the count at least. Like it was 1, 2, 3, 4, 5, 6, 7 people then. Richie stepped away. Five of 8. Oh, I need one more. No, wait, that was a 7. So yeah, you know what? I do want one more to see if we do hit. Oh, there's one more. I want one more to see if we do create a tie. I want one more vote. If one more vote creates a tie, then we go. Then I'll cut it, and I will have to bring in the second person. And I will have to cut the tie break. But you know, actually, maybe not. You know what? 30 more seconds. There's one person who I don't. There's one person who it definitely isn't here. Oh, wait, am I being included in the count? Let's see. There's 9 of us. Minus me means 8. So there's 7 of. That means there's 8 of this. 8 of you. Good. Richie stepped away. So it means 7. So yeah. Who hasn't voted yet? I wonder.
This is a really good way to see whose camera is killed, but isn't actually.
That's what I'm wondering. Let's see. Again,
class.
Richie did say BRB, so I'm assuming Richie's not here. Alita, there's Alita, so I'm assuming she voted. David and Emilio, can one of you speak?
I voted.
Emilio's here. Nice. So David, are you still here?
David's playing around. David's playing around with CRISPR. He's like,
Wait, did I hear him? Hold on, I think I hear David.
Yeah, I'm
You
here.
there, David? Did you vote on the poll yet?
Voting right now.
All right. And poll, because Richie at least mentioned that he's not going to be here, so I'm assuming he's not here. Share the results. I think you can see. Can you see this on my screen?
Yeah.
Yeah.
Oh, good. Okay, on the chart.
yeah.
So it looks like Max Freak, of course, wins. I knew I was shooting myself in the foot by adding that one. We'll bring in Max Freak for that one. Yeah, frequency. I was waiting to see if frequency would tie, but David brought in. David and someone else brought in ratio, so it gave Max Freak the win. Could Richie come in and bring the tie in? Definitely, but too late now.
Someone
that's the
call
case,
Richie. Someone call him.
He actually at least put in the chat that he'll be right
Hold him in.
back, so all good. Get there, let's do that. Let's clean up our screen and let's see if I can write code in about, well, I'm assuming we probably have 10 because I know sometimes runs a little late, so we'll see. Let's see if it jumps in, but let's see. All right, so first things first that I want to clarify is that let's create our way of storing the frequencies. We want to use a hash map. So let's start with that. Start there. So filter here. So we'll call this one freaks. Just have fun with it. Freaks, and that'll be. And since we know that there's going to be 4 characters, I know some of you would probably go through the process of checking to see if it exists or not. What we can actually do here, because we know there's 4 characters, and only 4 characters, we can actually kind of cheat a little bit and just simply do freaks add a 0. And just to save me from having to do stuff later, I'm just going to do this for once. It's just to save me that extra conditional statement in the loop later. See and G. Does that make sense?
Oh, yeah.
Because I never want to act, because I don't want to go through one and then have one of these letters not exist, do I? If the
Hmm.
letter doesn't exist, I do want representation of 0, don't I?
Yeah.
That's
Yeah.
a key item here I do want. So that's part of this as well. This is making sure that I do have each character represented in the frequency, even if they don't exist in the string. So since in this string, I do want to know the 0 occurrence of letters that don't exist, I do want to bring them in early instead of checking to see if they exist and create them when I see them. Because we've seen the example above here, there were no C's. So I don't want a hash map with no C's, do I? That could cause
Oh, I
some
see.
issues with the logic. Evan's now seeing that.
Hmm.
I don't want any issues with the logic later where I'm not including C in my testing.
Otherwise,
So now
those
the very
cases
easy
are
thing
gonna
here is I'm
fail.
just going to create the character array. So characters, what is it? Two array, right? Or two char array? What's
Char
the
array.
method
Two-char
again?
array. Two-char array.
Right. I always think in JavaScript's two array or method. It's one of the languages has a two array method. I can't remember who it was, but someone did. Two char array. And then we're going to go ahead and for this one, we're just going to loop through each character and add it to our frequency. So very simple. For C in characters. So I'm going to do freaks. Oh, it's not as put, isn't it? Put. And those things you got to keep remembering with your maps, and that's why again I've mentioned it. Like I said, mentioned to Cullen. That's why it's perfectly fine to jump over to your IntelliSense quick or IntelliJ quick if you need to remember what if hash map is put or add or set. Any of those.
Okay. Yeah, that's what was hanging me up when I was jumping back in class again because I
Yeah.
knew what to do, but I was like,
Yeah.
HackerRank was not helping me.
Yeah, and that's one of those things where I'm 100% saying 100% feel free to jump ahead and go ahead. And if we needed to confirm this, jump over to IntelliJ, create a quick hash map in a test system and see if it's put or add, see what shows up. Or pull up the documentation, whatever you need to do to make sure you're fine in that. If I remember correctly, you can still use put even on a character that already exists. I'm going to put C again. This I'm going to do Greeks dot is it get.
Yeah. It's get.
I'm just going to bring cheap in here for a quick second. Does not have IntelliSense. I thought it did. Guess not. Dang it. Dang, I'm not open IntelliJ, aren't I? Oh, right. I have a new laptop. I don't have reset my laptop. I don't have IntelliJ installed right now. Dang it. All right, it's fine. It's get.
Yeah.
Okay.
Mhm.
Thank you. +1. Sound good?
Mhm.
That look good? Again, we're using +1 instead of plus because we can't assign to this. So always be careful there. Some of you might be ready to habitually just go like that. That's actually going to cause an error because you can't assign to a .get method. So you can't reassign back to it. So +1 is what we want to use here. So we do put into C what we currently have in C +1 because we found a new occurrence of it. And that should give us our frequency system,
Except for
right?
you got to put a semicolon after 33.
Yes, I do. Again, this is one of those times where, again, you know what? Screw it. Let's do system dot out. That. Freaks. Just to make sure that
Semicolon.
this works. Is that?
Semicolon is
Yeah.
36.
Dang it. What's it want for me? Oh, whoops.
Wait, look at the parentheses.
Parentheses.
And
Oh, single quotes. Double quotes is string, single quotes is char. Remember that.
Yeah.
There we go. Let's take a look. Our output A equals 6, 0, 1, 1, which is what we have. So that is getting our frequencies. Again, don't be afraid to do this stuff. Test your code and do this in your HackerRank system. They like seeing developers that actually test their code as they write it and don't just assume it works. So don't be someone's like, oh, I need to hit this button as little as possible during the interview test. No, I cannot stress that enough. If you only hit it once, they're gonna be like, they didn't solve this here. They might come off as suspicious. So don't be afraid to hit the run code button, test things, run things first. It won't invalidate you, but always just be aware of that. 5 minutes. All right, let's get the text message from Arnell. Knew we got a couple more minutes. So we have our frequencies. So the first thing we're gonna do quick is just test to see if this is valid. To do that, we need our max freak, as everyone seems to enjoy. So let's do int max freak equals,
Gene.length,
is it size or length for a string?
length,
Thing is,
with the double parentheses.
Yep. That. All right. And then we're just going to simply do an if, and this is just going to be, I might make this would be one of those functions that probably make simpler. I could iterate through this, but you know what? I don't know if that's going to be the fast way of doing it. I don't know what the fast way of doing it. So
The
let's just
cliff,
go
it's
ahead and,
gene.length divided by 4.
oh, thank you. We're just going to do this for now. If you want to make it something simpler, you could, but for the moment, we're just going to do things like get a, yeah. Equal to max freak. And get C to max freak. And freak get C to freak. And get C to max freak. We'll return 0, right?
0.
yeah.
Yeah, 0.
Is that the
Yep.
base case? So that's
Yep.
if it already.
If we got
worked.
like this guy here,
Right.
we got the AA, GTG, CCT, since that's already steady, we don't want to change anything. So our minimum substring to change is 0. We're not going to change anything. That's what this is. Yeah, that's our base case. Good use of the term. Now I want to see, let's see, expect output. 5. Okay, both of these, either one of these show us a good one. So what we could do is do a, not that, I'll do this, for ACTG. Aw, did not look not good.
Freaks. It's freaks. That's why.
Oh, thank you.
Unless you want to just, oh wait, no, never mind.
Could change this to chars, but too late. Let's catch freaks. And this is why it's good to run code consistently. Max Beck.
Oh,
Didn't see that one.
You got those capitalized too. Oh,
there you
Got
go.
that. Got that. And just to confirm, let's make that a 12, just to make sure we're getting the 0 from here and not the 0 from there. Good, we're still
Oh,
getting the
yeah.
0 from our if statement. So always be aware of that. Always be aware of your potential false positives. Some of you are ready to just accept that as is. You're like, oh, we got it right. I could have been getting the 42 return because I had them both as zeros. Always be ready for that. Don't instantly accept your responses. Double check, like, oh, wait, could I have gotten it again? Oh, yeah, I could have. So you know what? Let me just quickly change this to something else to make sure I'm getting this return and not that return. Always be ready with those. So we have our base case. This is definitely something we could try changing. Maybe make a function where we iterate through the map or something to check this a little better, but that's fine for now. If it's not, that means we are not matched. But I do want to make sure there is going to be, I am going to need to constantly check if my frequencies are what we call valid. Remember when we said, hey, are my counts valid, meaning they're all less than or equal to our limit, right? Our max freak. So I am going to need to do this constant check to see if the map I have is less than or equal to the max rank. So I should probably make a function for this one. Let's do that. I'm going to create an is valid function. So private static bool is valid. We'll create our int and our hash map. Sorry.
Character, comma, integer.
Also map for the function because again, we don't. Yeah, we're using it for something specific, but again, for this case, it's fine. And again, what we're going to do here is we're going to just check to see if all we're going to change here is that this is less or equal to. So I'm actually going to borrow this if statement again, paste it in, and just change each one of these to less than or equal to. Why did it do that? Oh, so that's an interesting thing. So it'll actually treat those as like curly brackets and square brackets. All right, let's not do that. Again, this isn't telling us that the item is steady. What this is telling us is that we can validate, we now currently have a map that we can modify. That our hash map, our frequencies are something that are counted in a way that the unknowns are modifiable. Remember that at one point during the one above here, at one point, our hash map looked like 2000, remember? We had the 2A in the top one. That one we had like 2000, or no, it was in the bottom one when we went from left to right. Right. Because, and we had the substring of C, of 6, remember? Because we cut out these 6 characters because we only had with the 2 A's, and all of these were being excluded, remember?
Mhm.
So at one point, our hash map, our frequency map will look like this, and this is considered valid for us. All of the characters are underneath the frequency. So that means we now have a substring that we can modify. Is it our optimal? We don't know yet. But this is one we can take and say, yes, what we've currently excluded is legitimate. And so we can take that. So we're not looking for steady. We're looking for, is the current hash map something we can modify? Is our hash map valid within the max frequency? Equal to or less than. That's all we're looking for. Clear? All right, let's see if we can do this quick. So, yeah, good. So, I'm going to create int I equals 0, equals 0. And what I'm going to do is do a while do. For the moment, let's do while true because we don't know what our condition is going to be to break out. We do need to make a break at some point, but for the moment, I don't know what my condition is going to be to end this. So we're going to use while true for the moment until I know what my condition is going to be. The first thing we want to check is if is valid. Max freak. Freaks. Oh no, if not valid, let's go for the not, because we want to move the right. We want to move I. A. All right, we should make pause on this, let RNL speak, and then we'll finish up if we can. We have a little more to go on this, so what's that? I want to get this stuff going. You guys want this? RNL, welcome.
Hello, my brethren and sisterin. I bring thee greetings and tidings.
I'm gonna pin you.
Awesome. Wonderful. Can you also give me that some magic juice?
What's
What's
magic?
magic?
Oh, your hosting capabilities, I'm thinking. Even though you are perfectly allowed to share, but I will definitely make you co-host.
Yeah, I just need to do a
100%.
couple other things.
Make co-host. Done and done.
There we go.
The
I need to
power.
invite a special guest.
Ooh.
Ooh, okay. I'll be right back. One moment, please. Hey, do you have a passcode for this meeting?
No.
Good. All right.
It doesn't show one, so I don't think there's one.
That-
There is one in the link, but if you pull it from the Zoom system, it should pull the password as part of the URL.
All right. I miss you guys. What is up?
Let me turn off the pin for a second so you can see everybody.
I miss y'all. My family.
Oh, not
What
that
are you
one. I just pinned myself. Hold on. I removed the pin.
We should be having one
Okay.
more person joining in. Let me know when they join. Let me put my join alert sound on so I can see when. Here it comes.
Ah,
Doggy. Dun, dun, dun,
glad to see him in.
dun,
Yes.
dun, dun. Where is he? 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 Where is he?
Are you talking
Triggering. There he goes.
There he is.
Hey.
All righty, everyone.
Yeah.
So this Zoom is a special Zoom. All Zooms are special with us, but this one. So I wanted to talk about the process to begin you preparing to interview. And I want to start off by saying that after completing career devs, there is a very specific type of computational algorithmic skill that you need to hone and master. I would say even muscle. And John, when did we begin the process for you preparing? How long ago, John?
Oh, a while.
I mean,
Yeah.
no. I mean, let's get really integer-like.
Integer like months, weeks, days.
It's a big blur right now.
Okay.
Was it
okay.
1 month or 2 months?
I'd say 2 months, maybe.
2 months.
Yeah.
And you took your test for citizens, right?
Yes.
Yesterday?
Yes, I
And
did.
how do you feel like you did?
I think I did pretty well. I think I
And
did pretty well.
And I know that you did pretty well because they told me you did well, but also you received a second interview,
Yeah.
right? And that interview took place today. But my question is, 2 months ago, when you first began on this trek, if you had taken yesterday's test, how would you have done?
I probably got a 75%. I think that's what I
No.
would have got.
Which would not have been good enough to get hired,
No.
right? What percentage did you get yesterday when you took the
Well,
test?
100%.
Or Monday? You got 100%, right?
Yeah.
Yeah, so, and so what I want to say is that this is going to be a process. John, the first practice test that we gave you from HackerRank,
Yes.
how did you do on that?
0%.
0%.
Yes.
The reason why I brought John here is because it's easy to get frustrated with the process that you're going to go through. John, the last 3 tests that I gave you over the weekend,
Oh.
on a scale of 1 to 10, or on a scale of 1 to Mike Tyson, on a scale of 1 to Mike Tyson, how difficult were they?
Oh my gosh. Muhammad Ali.
Right? Muhammad Ali plus Mike Tyson. But, and the really cool part about it is that John's going to be available. I think Marguerite is going to be available because they have these tests fresh in their minds that they've completed, to bring you through this process. Also, I heard from one of our graduates today. So this is just a side note. Emerton, a career devs graduate, who ended up getting one, I think that at the point in time, it was the highest starting salary for any graduate. Now, he had 4 months of experience as an intern, but he landed a job making $140,000 a year at Amazon Robotics. And today, he just turned down a job offer for $210,000 for Microsoft. Turned it down. He was like, nah,
Jesus.
210, no thank you. Crazy. I was like, bro, congratulations. The process is going to be grueling. It's going to be extremely grueling, algorithmically challenging. John, can you mention what was your score on your first test that you took?
0%.
0%. Everyone write that down on one piece of paper, 0%. And because I'll tell you what the people at Citizens have told me, they said, Arnell, everything else on HackerRank is crap. It's nice. It prepares you to get ready to get prepared for the real private HackerRank tests. 30 days of code has nothing on the HackerRank test that we're going to give you. So John, I would like you to talk about the process from going from 0 on your first test. What was your process that you went through to go from 0% to 10% and then to 20% and then to 30% and then ultimately to 100%? What was it that helped you? Or what did you do?
I got really meta with things. I started peeling my process apart and trying to discover why I wasn't performing well in those, pressure challenge situations.
Pause.
And yeah.
He got very what? Can you guys tell me?
Meta.
Meta. What does that mean?
Perspective.
Introspective. You have to get within yourself. And one of the things that we did, we had John do a couple of tests, and I believe, was it Cliff and Margie who were watching you take the test?
Mm-hmm.
And what was their first feedback to you?
Slow
What was
down. Slow down.
All right. To slow down. And why were they telling you to slow down?
Oh, because when you rush, I'm using Cliff's words, I'm going to coin them one day myself, but pitfalls and rabbit holes, these things that will lead you down the wrong path, or that you fall into, that you get, something bad happened to you in that pit. And, those can prove really costly. And I had to learn how to avoid those first and foremost. And I felt like as long as I can avoid those, I will eventually get to a good solution. But once one of those comes into the picture, man, if you only have 15 or 30 minutes, then you might not make it. Yeah.
And the big point that I want to touch upon there, he said, when you rush.
Mm-hmm.
But for John, he didn't know that he was rushing because it was his natural cadence. And because what Cliff and Margie would do, they would say, okay, how are you attacking? A new question would come up on the screen, and they would say, okay, how are you approaching this? And he would talk out loud. He would talk through his process, and they would say, oh, you missed something here. You missed something there. Oh, did you notice this? And he was like, oh no, I didn't notice that. So he had to really, what's happening for many of you, you're trying these algorithms, and you may be running into walls. It's because you're not able to peel back the layers of your process and step outside of yourself and observe yourself externally in the way that you approach problem solving. So it really is a about slowing down. You're not just analyzing the problem, but you're analyzing yourself. Being able to externally analyze yourself. The way that you think. And once you're able to do that, so we'll have, John's going to be available for the next couple of weeks until he gets hired full-time at Citizens, which is going to happen. And it really is, so John was a test case. So this is interesting. Career Devs has been, and it always is, a process for Cliff and myself to slow down and analyze what we've been doing wrong. How we can improve. This was the first time, John was the first time that we had someone sit in with someone while they were doing, one of these tests. I'm about to spend $5,000 to get the full version of the HackerRank professional testing system. I'm like, real $5,000. I was like, oh my God, I'm like, really? I was like, all right, but we have to be able to do it. It's worth the expense.
Yeah.
Cash out some Bitcoin, right? It's been a good decade. So, actually, I did just celebrate my Bitcoin. Actually, I think my Bitcoin anniversary is coming up. Yeah, I think next month, in fact. So, I think that's the first month that I purchased Bitcoin 10 years ago. Crazy, $91 per coin.
Jesus.
And yeah, and I thought, like, man, by 2020, it might reach $5,000. Right. So,
Yep.
Process. John, I was talking to Cliff about this. There's so many test cases that they give you, right? That they throw at you. I want to be able to recreate some of these problems, not using exact answers to questions that they have on their test, but maybe recreate one of these things. And then, Cliff, how difficult would it be to have our own test cases with some of these questions?
It's not too difficult. It's just knowing that we are aware of all the edge cases that we might not think that they have that we might not think of. It's really the edge cases. Creating test cases is not too bad of an issue. It's just knowing if we caught all the edge cases.
Yeah, so I don't think we need to catch all of the edge cases. We need to probably have like 3 or 4,
Yeah.
right? And sometimes just 2. Does it pass
Yep.
on this? Because then, John, did you find yourself in some of the cases when you were passing a majority of the edge cases or the test cases, but not some of them?
Yeah, especially on the harder ones.
Probably timeouts.
Yeah, exactly.
Where elegance and refactored code was an issue, the way
Yeah,
you were
well,
solving it?
The approach, actually, yeah, the approach in general, it was a inefficient approach.
So we're thinking through this process because it's like, I think we're doing these as practice tests, right? But companies are paying for this for real tests when they're trying to interview someone. And so it could get really, really expensive, really, really fast. How many tests total did we give you, John?
A lot.
Yeah,
A lot.
we did
7. Yeah.
Four just in the past weekend.
Yeah, at least 7 or 8.
At least
yeah.
7.
Yeah.
So if we do 7 and I get 30 tests per month, and for 5,000 and like 10,000, I think we get 60 per month. For
Yep.
50,000, I think we get more. hey, for $1 million, you can test as many people as you want, Arnell. Right? Just give us some of those Bitcoins. So we're trying to think of a way to have you guys do these things.
Your own craft,
On what?
your own craft career devs testing platform, perhaps.
Yeah. Oh, yeah.
Yeah.
That, trust me. That's, I know
Yeah.
that's where it's going, but sure.
Mhm.
Yeah. Let's just create our own
HackerRank testing
multi-million
system.
dollar HackerRank testing
Right.
system in our spare
Yep.
time.
Yep.
Right.
We're technically trying to do what Uber did first. Uber in the beginning used Google Maps and eventually they then created their own mapping system. So
Yeah.
kind of like the process we're kind of trying to look at. Similar thing. Use HackerRank for now, eventually create our own in the long run. Of course, we would rather have that now rather than later.
Yeah.
Oh,
But most importantly, what I want to do, John and Cliff, is have the two of you get together
Mhm.
and break apart maybe that first test that you sent, John, the first screen recording that you made.
Yep.
And create how many questions was in that one? I forget, whatever, but
Multiple
recreate
choice
that
captions
one.
would be easy, yeah. This was
Yeah.
just the coding ones. Yep.
Yeah. The multiple choice ones are not a problem at all. It's
Easy.
just the
No.
coding challenges are really where we need to go and where we need to get. Any questions for John from anyone?
I have one. This is Titus, John. What's your availability, just in general?
Oh, I'm very flexible. I'm a morning person, but I'll meet at night as well.
Nights work for you?
I'm doing this full time and run up to the job. So anytime, Titus.
And
Seriously,
what I will
it
say,
can be short notice too.
so what I will say for John, so often I'll tell you what happens. When we get to this point, when students are ready to interview, all of a sudden, not all the time, but sometimes students become smarter than Cliff and myself. And the advice that we give is becomes optional advice. Like, hey, did you guys do this? Oh, no, well, I know you were saying to do that, but I did this. I was spending time on this. And then they go into the interview and it's like a woodshed bloodbath. Looks like a Friday the 13th horror movie. And Cliff and myself, we know before they go in that it's going to be bad.
Yeah.
And so, but John he really, really trusted the process. And he was patient. There were times when was the first time I said I was going to send your resume in, John?
Oh, well.
Integer wise. No, let's be honest.
Okay. It was 1 month.
A
Maybe
month
not.
ago, I said, all right, John, you're ready to send your resume in. He'd do a test and I'm like, I can't send it in. I'm like, I can't send it in. And so I sent him more work. We'd send him more things to do. John, here, do this, and that. And he was patient. Trust the process. Trust the process. I wanted to send him in when he was what? She was not ready. Kevin Hart. When he was ready. When he was ready. So
100%.
everyone here is going to begin this process of working on yourself, working on your algorithmic approach. 30 days of code. It's a good practice for that cadence. And I know that right now, Cliff, you've had them doing time tests.
Yep.
Cliff, on
Easy
HackerRank?
algorithm and a timed algorithm. Yep.
And let's start with James. how do you feel like you've been doing with the timed test?
Not too well with them because I'm not really getting the time I take to solve the problem probably in my head. By the time I take time to code it, I don't have enough time left. And I always don't get to solve the problem completely. It's like I get part of it, but it's just always just this one wall that I can't get over to say, yes, this is the rest of the time, or the rest of the code will make it work, or the rest of the problem solving that needs to be done. I always seem to have like a wall that I always hit. I'll get like halfway through and I'm like, oh, I don't know how to do the rest of it.
Mm-hmm. Got it. Evan.
I'd say, well, at first I really struggled with them and haven't really gotten any or very few test cases working. And now I'm starting to peel back like where I went wrong, what steps I need to improve my process to achieve solutions like I did in this last challenge.
Mm-hmm. Got it. Elaine.
I can do some things, but I can't do everything.
Okay. And when was the last time you completed 30 days of code straight through without stopping?
I am stuck on day 6 and 8.
Okay.
I've never
Yeah.
gotten past those.
Cullen, where are you in 30 days of code? What's the furthest you've ever gotten straight through without stopping?
Coincidentally, it's kind of where we're at with our challenges with the binary tree. I forget what day that is. It was back when I was in Java in the fall.
Mm-hmm. All right. Hello.
Tim.
Wait a second. Hello.
Well, hello.
I was hoping you didn't forget.
No, not at all.
Awesome.
He still does it. every day.
Inside joke, guys. Inside joke. Does he still say it?
Yeah.
No, he still does it. I actually have no idea where it started. I just figured that was David. So apparently it's an inside joke that I'm not aware of.
Started
Like, oh, that's
many,
just David. It's just how we always say hi.
No.
started many moons ago. All right. And how are you doing? How
Good.
far? When's the
doing
last
good.
time you've gone straight through 30 days of code?
The last time that that Cliff had us do it,
And how are you doing on a time test?
horrible.
All right. And what's the most number of days that you've gotten to in 30 days of code?
I've done all 30 before, so
All right. Done all 30.
but it's still like I've always had issues with what we're on right now, which is binary trees and recursion. So I know I'm doing awful.
All right. Good. Who else do we have down here? Is that Emilio?
Hey,
Yep, that's Emilio. Emilio, do you see how happy I am to
Oh.
see you?
Yeah, Amelia, can you bring it down a notch? Actually, it's a little too much.
sorry, I'm
enthusiasm.
too excited right now.
Hey, too excited, buddy.
So let's see. Emilio, how are you doing? With
I'm struggling with the timed.
again, that's fine. When John had completed career devs, it's a struggle. It really is. I don't know. There's like the people at Citizens, they said, listen, everything else that you do is one thing, but when you get to these tests that we're giving you guys, and these time tests especially, it's a different animal. So we're gonna work with you guys. We're gonna do some mob sessions, and we're going to probably do 30 days of mob coding. And it would be great to do more than just one in a class when we can get through a couple of them. And let's start at day 1. And if we can get number 1 done in 5 minutes, fine. then have someone else go to the next one and just keep going round table. And then what we're gonna have John and Cliff, and I'm gonna try to tag Margie to come in for a little bit of some of that, and maybe even Isaac. Yeah, maybe even Isaac. But,
That's a good one.
that's going to be the commitment for you guys on these classes. What time does, in terms of the start time for class, how many people aren't able to start at 5:30? And I haven't gotten to everybody yet. There's still a couple more faces that I need to talk to. I see Titus and Richie. I'm going to get there, but just a little side tangent. How many people cannot start class at 5:30? And if you can't, that's perfectly fine. This isn't an indictment. It's not like the principal's here. Don't treat me like the principal. I'm Arnell. I'm cool. I'm like the cool dad. Yeah, you can smoke cigarettes. Fine, son. Go for it. Yeah, you're only 12 years old. Smoke cigarettes. So
Don't let your kids hear that.
yeah, my kids are over 12 already, so that's good. 13. Hey, Dad. All right. Anyway, so how many people is 5:30 difficult? Because I want to try to make sure if I bring people in from outside, that we bring them in at a time that everyone can start.
I would prefer earlier classes, but I'm flexible, obviously.
So, but 5:30, everyone's fine with?
I agree with that sentiment. I used to have an issue getting a class at 5:30, and then we started at 7, and then my schedule now is 5:30 is way better than the 7:30.
Okay.
You were late today. Titus, you were late today, though.
My schedule now 5:30 is
Okay,
better.
starting
than-
today. Okay, starting
Yeah.
today.
All right.
Okay.
No,
Got it, got it.
just in I'm saying like
In general.
I don't know, maybe the past 4 or 5 months, it's shifted. My schedule's shifted. That's all. So
Okay. No, that's good to
that's
hear.
all.
I'm glad that it's opened back up. That's great.
All right. Good
Mhm.
stuff. All right. So then today is Tuesday. Thursday, we're going to do 30 days of mob coding. Hopefully it takes us just 10 days to get through that. I just want to go through 30 days together when one person is driving, everyone else is assisting. And has everyone at least gotten through? Elaine, you said you're on number 6 right now?
6 and 8. I think I did 7.
Okay. Yeah, let's start off because the goal of this is the person that's driving especially for Cliff and John to analyze and help the person slow down and look out from the outside in on what they're doing to find, and as they're talking through what their processes, their flow, their creative process, their ideation process, that hopefully other people will be able to give some comments. And so, we really want it to be at pace, but we do want to be able to help people identify. So that's what I'll say. On Thursday, we'll start doing that. And as soon as we get through the 30 days of code, hopefully in 10 days or less, because I think we should be able to do. Cliff, what do you think on day number 25, 26, and 27? How bearish do those things get in terms of time complexity, time requirements?
I really don't think any of them take longer, like 30 minutes to an hour, because they're very targeted challenges usually.
Mm-hmm.
So most of them are still very targeted challenges. Some of the time constraints on them is more just doing the research on them, watching the tutorial video, reading up on the article on it. Usually the algorithms, from my understanding, are usually not that horrible.
All right, good. Titus, my brother from another. How have you been doing? How are you feeling? What are you stuck on? Titus, you're on mute. There you
I'm
go.
sorry, I had audio issues. Can you repeat that?
Yeah. So how are you doing? What do you feel like?
I'll
What's your
go
block?
through with the 30 days of code. I got to day 24. And with the time thing, I'm getting my ass kicked. I need to do better. I just need to honestly just work, reps, muscle memory.
You know, so one thing that's interesting in the new intro core that we have, Gabe is co-teaching it with me. And I had Gabe give them an assignment. They did the homework assignment. The next day, we asked them, I had Gabe ask, on a scale of 1 to 10, how difficult was the homework? They said around a 2 or 3. How long did it take you to do it? They said, oh, maybe 10 minutes or less. I said, okay. Here's the same assignment from last night, but instead of hotels, it's rental cars. Everybody do it. We're going to time you right now. 30 minutes later. They were still struggling with it. 40 minutes later, they were still struggling with it. And so then I asked, and I had told Gabe it was going to happen before it happened. I said, this is what's going to happen today. They're going to say it's going to be like a 3 for the homework, and then it's going to take them an hour to get it done when we give them the different assignment. And he was like, well, how did you know that was going to happen? Oh, and first I started off by asking him, hey, how are the students doing? He was like, oh, everyone's doing great. And I said, no, they're not. They're doing horrible. He goes, wait, what do you mean? Right? And, so what I'm hoping will come about from this shared experience is that wealth of insight to see our blind spots. Whoa, who's that?
Got it.
Someone's at a party.
Got it.
And not that I'm mad, I just want to be invited. All right. So as you go through this process together, as we go through it in a group, I'm hoping that we'll be able to, because I know that we'll be able to see your blind spots and point them out and help you to see them. It's like, oh, wow, this is where I had a blockage. And that's really the goal, to find, and I'll tell you, for John, the first test, he was rushing. The second time he did it, he was rushing. The third time he was rushing. And by the time he did the fourth one, I was like, "Spécialiste, comrade. You're officially Russian." That was an Arnell joke. Добрый день. Da. Slow down or we break your legs, bring you to the gulag. So we had to bring him to the gulag. And he's no longer rushing anymore. He's finished.
Now, my biggest moment that I remember with John.
Wait, that was a good joke. He's not rushing anymore. He's finished. Get it?
That's good.
I totally know what I was speaking. Then as soon as he said, I'm like, wait, there was a joke there. I completely didn't register, and then it suddenly registered in my head.
He's done. He's finished.
It was so
Richie,
good. Titus dropped.
It was so good. Titus is like, I'm out of here. I remember this, Arnell. I can't take this anymore. Richie DeLuca, how are you? Where are you, Richie? What are you feeling these days? Talk to me about your emotions. You're on the air with Arnell.
The times are kicking my ass a bit. Kind of depends on the problem with me. I think Jim kind of touched on it earlier. It's like I take so long to think of like the actual solution in my head. I don't really get enough time to code it out. And then I think 30 days. I want to say day 11 or 12. I think was the furthest I ever got.
All right. Good. All right. Yeah. So you're all in the same place that John was when he started. So, Alita.
Hello.
Last but not least, how are you, my solo student? It was just you and I for a while, wasn't it?
Yeah.
In class.
It was just Gabe and me, and is my first real cohort.
Yes, it is. You were like, you were
jumped right in.
outcast. You were banished from society for the longest time.
Man, I was like in a solo boat while you guys were all on an island. No.
Yeah. So, first of all, how's it being in a cohort with other people?
Definitely helpful. That way I can
Yeah.
just hit people up and be like, hey, let's
Yeah.
work.
Good. Well, I'm glad you got a chance to get let out of the basement and into the regular part of society. How are you doing? What's going on? How are you feeling? Do you have any blockages?
I mean, like, so you've done like 3 timed algorithms so far. First one wasn't bad. I was like pleasantly surprised. And then like the second and third, like nothing. But yeah, I almost feel like with both of those, I try to give myself a lot of time to like code, but also think. But then like I'll be able to think of a solution for like the first half. And then like the second half where it gets the nitty gritty, like more complicated stuff, I'm just like thinking and thinking and thinking. And I'm like, I can code the first half, but I'm not going to get anything if I don't have the second. So I'm just like focused on that. And then I do code the first half. Doesn't solve any test cases. I need the second. So
Yeah.
that's
Is it paralysis of analysis is it the time factor?
I don't feel like it is. I just feel like I can't figure it out, but that's exactly where I guess watching myself again a few times, maybe I'll find out it is panic, but.
Yeah, so this is going to help. And when having other people that are observing, and hopefully, since we're doing it in a mob setting, we won't have to, everyone's going to be learn from other things from other people. There's something that, an issue that I have that it's like, oh, wow, I think that speaks to me. That helps me as well. So, so Thursday, Cliff.
Yep, we're starting nice and early. I like it.
5:30 mob session, and I'm thinking, could everyone type in the highest number that you've got to on 30 Days of Code in the chat? All right. Lanello, is that really your name? Elaine?
What? Where's my name? What's my name say?
It said
Lanello.
Lanello.
Oh, I have 2. I have one for school. It's Laney.io. Input and output.
Laney.io.
I have one for school from school, and I have this one that's on my desktop, and I gave them different names so I know when I'm using it anytime.
Makes sense. All right. I didn't see the I at the end. Lane.
It looked like an
I-O.
L. Yeah, it looked like an
Okay.
L. I see what you're saying. Yep.
Yep.
Oh yeah.
I thought you were about to put me on something new. All right. Elaine, it's great seeing you, by the way.
Thank you. It's good seeing you too. Your energy.
Thank you. We've had some great times, great conversations, just connecting and bonding. Since the Waterfire building days.
Since the Waterfire days. Yep.
And you're
When we
plugging
had no
away.
heat. We had no heat in the winter.
No heat.
That was good times.
No heat in the winter and no AC in the summer. But we had free rent.
Yeah. And it was beautiful. It was good.
Yeah,
Cold.
it really was.
And hot. And noisy.
Awesome. Is Christian in this class?
Yeah, he wasn't feeling good. He had to drop out. Started having a headache, I think. He was in earlier, then we lost him at some point.
Okay.
Yeah, I'll check in on him, see how he's feeling.
All right. All right, that's it. It's 9:20.
Yep.
Between now and Thursday, if you guys want to brush up on the first few examples of 30 days of code, see if you can get to like past day 6. And I'm going to say the person that will be driving on Thursday will be so many screens have been turned off. David, you don't have a video monitor? I mean, whatever that thing is, stupid thing is called, a camera?
I do. I just don't want to offend anybody's eyes.
All right.
Let's see.
Yeah.
If I can get
I
it.
think, yeah, try to get it ready for Thursday if you could. And Emilio, Richie, if you guys could. Let's go in this thing. Like I said, guys, listen, I believe that what we experimented with John Saylor for a month and a half or 2 months, I believe you guys can do it in 30 days. Because a lot of it was trial by error with John, and it took some time to do this and do that and figure it out. But you guys could do this in 30 days. You should be interviewing. And again, he was at 0, frustrated, couldn't get it, kept hitting his head against the wall. And we figured out a process to get him across the line. So on Thursday, how about we have Richie, would you mind driving the boat on Thursday?
I can give it a shot.
And the way it's going to work, you'll work on the problem. And as you work on it, everyone else is going to be watching you. And you'll talk out loud about your thought process, how you're approaching the problem. And Cliff and John may even ask you questions about your intention, your thoughts, your angles of approaches, what you're doing. And that's for Cliff, which problem should we start on 30 days of code? Which day?
I would probably double check, but probably actually right where Richie is a good starting point. So 10, 11, 12, right around there. That way we skip a lot of the early super easy ones that can be solved in like 5 minutes. You get the ones that at least take a good 20-minute time. 20 minutes.
You know what, Cliff?
Yep.
I would think that I'm going to jump in there really quick to HackerRank. Which one is it on? Which account is it? HackerRank, 30 days of code. Is it this one? Nope, not that one. Which ones do you guys think we should start with? How about that? Could everyone go to HackerRank 30 days of code and then just type in a day that you think we should start with? Only one integer, one number. Don't type in more than one. Just which day number do you think we should start with? Oh man, log in. There we go. Ooh. Why did I do that? Oh, probably it's not a sign in for that one. Really? Jeez Louise. No, I wonder if. the heck?
Three responses so far. Come on, people.
Mm, come on. Oh, well. Oh, crap. When did we start? Man, I can't tell when the
David Jones,
one.
10.
Okay, got it. All right.
Because his previous was 30, which is 30 days of code.
Let me see what 8 is. Dictionaries and maps.
Mhm. I'm actually game with that because 9 would be recursion. That includes the day 11, which is one I definitely wanted 2D arrays. So I'm game with that. Titus is back.
Yep. I think 8 it is.
I think so too.
All right.
Which isn't.
All right. So yeah, we'll start off on number 8. Richie, you're gonna drive for that one, and then just randomly go around robin Cliff.
Yep.
And have each person take the next one, 8, 9, 10, so forth and so on.
Sounds good to me.
And the goal is that by Thursday, Monday, by the following Tuesday, we should be ready to begin getting crushed by the first test. And again, like John, who got a 0% correct, it's okay.
Mhm.
It's absolutely okay.
Yeah. What I'm thinking is we might even finish with one of these last 2 algorithms that, as everyone here said, kicked your butt. We might do one of those as your final mob programming session. Do one of those.
Yeah.
As
But
final
first,
mob,
let's start off with 8
course.
first.
Oh, of course, yeah, no, I said that would be one of the last items I said after the 30 days of code. Yep,
All right.
that would be a nice way to finish up the mob programming.
All right. That's it, guys.
Cool.
We Gucci. Any questions for anyone? Any comments? Any thoughts? Any ideas? Hey, Arnell, I think this might be a good thing. You know, I was thinking maybe we should do this or maybe we should do that. You know? All right. Let's get you guys in jobs in 30 days. Let's go for it. All right. It's great seeing everyone. And if you ever have any questions, guys, if you have any concerns or whatever, anything, you can always reach out to me or Cliff. But you know, I'm easy to find. Easy to find. All right. I appreciate every single one of you, and it's great seeing your faces. I can't wait till we do a little mixer meet and greet type of thing again in person.
Back in Niantic.
Yeah, back at Niantic. Yeah, and there was a political event that I went to recently, and I had to get in. There's this test that takes 5 minutes for COVID. Before you could go, you had to take this test, and so you take it. It comes up it looks like an EPT pregnancy test. I was like, what, am I pregnant? You know, I wasn't pregnant, don't worry. I saw the concern looking at his faces, but so yeah, it tells you if you have COVID or not. And so if you don't, you're able to go in. So we may do something like that as well. I may buy a big kit. It's like $5,000 per test or some stupid thing, but we'll take care of it. All righty, guys, that's it.
All right.
Have a good night.
Good night, Arnell.
Good night.
Later, guys. Bye. Later.
Bye.
Cheers. Thanks, John, for coming in.
Thank you all.
Thank you, John. See you Thursday.
Yep. Please reach out, everyone. I'll jump at the chance to work with you anytime.
Thank you.
Thanks, John. Appreciate it.
For anybody else, if anyone wants is able to stick around to see the end of the code, we can. Otherwise, if you guys got to go, it is 9:30, so I won't hold anybody. But I'll go ahead and wrap up the code quick for anyone who can
I
and
just
wants
wanted
to
to
stay.
mention this so so I don't forget this.
Before
Just to let you know that Free Code Camp
Mhm.
actually has a GitHub pull. You can actually pull the whole code down. You can actually work with it. So you might be able to alter some of these tests to work with career devs. I mean, it's just you basically have a skeleton of tests.
I can
You
take a
just
look.
change them around because you can actually compile those tests. You can actually compile it and put it into a Docker, and then you can just run it. You can just run Free Code Camp on Docker, and you can just run the test and run without having it on a web or anything. And you can run it internally too. So it's pretty
Something to
cool.
look at. Thanks for the heads up. Yeah, so like I said, I'm gonna wrap up the code. If anyone needs to head out, you can, but if you gotta stay, stay. Again, it's being recorded, so it'll be up there. But I just want to wrap up the code for those who want to see it. So if all the numbers are within the frequency max, so 2 or less in our example, we want to move our I over 1, but remove the one we're looking at. So we're looking at 0. Remember, we're looking at 0 right now. And we want to remove the 0 items. So again, G, A, T, A, I, J. So I is pointing at 0, J is pointing at 0. We're going to first remove from the map one of the items at I. So, Greeks. That's why I hit the mouse button again. Greeks. Dot put. Oh, no, not Greeks. Characters. I. Greeks. Dot get. I. Minus 1. So again, what we're doing here is we're grabbing the character at index I, so the G. So we're updating the I, the G, and we're going to reduce it by 1, so that we're no longer including this letter here. We're then going to
parentheses. At least in
on
the
an array?
get. Well, in the get.
Oh, in the get, yes,
At least
yes.
the get.
Yep, which I did have on this side. You're right. Weird. Okay, yeah, I must hit the wrong key. Thank you. But I'm going to increment the I that it moves over. I'm going to continue. Jump back up to the top. Makes sense? So what happened here is, again,
You need a
6.
semicolon at 54.
Thank you. C0, 1, C0. Our G is now 0. Our I is now over here at A. And now 1. And we need a semicolon on both. Yep. So this is going to happen a couple times. So now this is the right logic for multiple times. We're going to go through this until we get to here. So this is what we're going to go through it. When I hit it again, we're going to go through again. Next character, we're not valid. We're at A6 still. So we still have the A6. So that's still going to invalidate our system. So it's still going to be not valid. Move the 6 to 5, add a 4. So you do this one, 6, 5. Right there. Right here, we get rid of this one, that's 4. We get rid of the T. Move I again. Over here to the A. Move the I here. And now we're at 2. 1, 2, 3, 4, 5, 6. So now we're at index 6. So I is 6. J is still 0. And now we're actually going to trigger true on our is valid. Our is valid is going to hit true because now we have 0, 2, 0, 0, 0. Every single frequency is less than or equal to 2 to the max frequency. And now else, once we have this, we now know that the current range between our I and J is a valid substring we can change. We can change all of these items, these 6 right here. So we're going to check that now. So now we forgot to create that variable for our current min length. So we're going to do min equals length again, as our maximum length. That's going to start us off at 8. So we have that kind of base case starting value. We could, of course, do max integer, but unnecessary. It's perfectly fine to do gene length. We're simply going to take advantage of that math. Sorry, do min equals. We'll take advantage of that math.min we saw last time. So some of you saw that last time, do comparing the two numbers. Do math.min min, and the other value is going to be our I minus j. I will always be bigger than j. So this is then which one's going to be bigger. And so we'll take that. In this case, of course, the 6 is going to get taken, so that's going to be updated. We then want to move our j over to see again, then see if we can add more. So now we're going to go ahead and do, I'm going to put the letter back, put characters j, matrix, dot get characters j plus 1. So we're going to put that character back into our array here. So this is going to go back up to 1. Our j is going to move over here. 1. And we're going to increment our j, which I didn't do yet. So j plus. I don't need to continue actually, so they have an if else. So we're not going to do the continue. That's going to wrap us back around. We're going to check is valid. It is still valid, 2 and 1. So then we're going to do the min again. Our 6 minus 1 is going to get us 5. So that'll get us our 5 length that we've been looking for. So our min's now 5. Right? So we then add in, we then move j again. We add the a back in. A goes back to 3. J is now here on 2. And now we can see we're invalid again. So not valid. So we're going to move the I over and remove the A again, back to 2. Move the I here. Got that, so then I is now 7. We check this, it is valid, but again, we're gonna go back, so it is valid, we're gonna go to else. We have 7 minus 2, which is gonna give it 5, so it's gonna keep the same number, so it's 5 compared to 5. It just takes the first letter, doesn't care. It's gonna move our j again. J moves over 3, and it's gonna bring the a back up to 3. I'm gonna hit is valid. It's not valid. We're going to remove the a again, back down to 2. But then I'm gonna increment I, but what is I gonna become? I becomes 8, right? Well, we should probably not do anything else, huh? So that should break us out. As soon as maybe one of these characters hits the max number, we should cancel out. So when it hits size, so I think that's a safe one. And just for the safe side, we'll do with either I, while I is less than gene.length, and j is less than gene.length. Just to be on the safe side, if somehow both get to the top. So as long as I and j are less than length, we're going to keep checking to see if we can find the smallest substring, moving each and over until we find that perfect minimal substring, regardless of where it is in the system. We could find a nice 3 in the beginning, but then go all the way over to the end and find a 2 size somewhere near the end, right? That's why we do this. We don't know where exactly the smallest could be. A substring of 4 could be in the beginning, and then all the way through we're finding 5, 6, 5, 6, 5, 6, and then somewhere in the end we find a substring of 3 or 2. And so that's why we do this system where just because we found a pretty small one, we want to go until at least one of these 2 letters hits our length, is equal to our length, and then we drop out. Once we drop out, we're simply going to return min. Let's see if this works.
You're going to need, yep, and the length needs to have parentheses too, on line 52.
Oh, right, these 2. Yep, you're right. I should probably save gene.length to a variable. I've used it 4 times now, I think.
Well, you got min.
Yeah.
Min's gene.length, is that the same?
No, it's going to change. Remember that? We're just setting that to start the default value of the the minimum substring. So let's do int, and since it's the character used in the example, we'll do in gene. We see this. We're going to go ahead and replace it with n. I also probably should have made that a capital N because it's not going to change, but it's fine.
And you forgot to add the semicolon.
Again, thank you. You're saving me from those, which is great. I'm accepting them. Oh,
I
we
just
did
have a
that.
habit of doing it. I'll probably do it in.
Oh, wait. What? Oh. Which means actually I can just do this. Eh. So just get the conditional here. If this is true, return true. If this is false, return false.
I don't
Simple
think
enough.
it's semicolon.
And yeah, that does need that, doesn't it? And my curly bracket's missing. There we go. Cool. All right. There's that. Let's run it. See if this works. It's missing.
I think you gotta put Boolean.
Boolean.
Yeah, I think. you
Oh
gotta
right,
put
I'm
Boolean.
thinking.
Yeah.
Yeah, I'm thinking Java. Thinking JavaScript. Sorry.
Yeah, you gotta be.
All right. And how many misspells do I have? Let's see. Freaks.
Yeah, I don't.
Looks
I don't-
freaks to be right.
Oh,
Oh,
because they did map. It's map. And let's just change this to freaks.
oh, that's why.
Yeah.
Yeah. All right. Got a 0. That's not correct. That's correct. Yep.
Oh,
So that's
you're
this,
still
right?
testing
Yep.
against custom
Right,
input.
Yep. I figured I'd keep that to make sure we didn't break that, I guess. All right, so let's
Oh,
see.
no.
Null pointer. At some point we did hit null pointer. Okay. 23. Did this hit a null pointer? How did this hit a null pointer?
Wait, what?
CTG, ATCG.
Wait, why is it less than or equal to max freak and not equal to?
Because once anything, because we want to include the zeros and ones as well. Because we're just checking to see if this is a valid item that can be modified.
Oh,
We're
okay.
sending a modified version of the map that has unknowns. We've eliminated some of the characters out as unknowns as possibly being changed.
Oh,
I'm trying to remember why we're getting what a.
Because it is possible to have negative numbers in this map because if it, the way the math is going.
Not necessarily no, because we only reduce it if we see it. So if it doesn't exist, we can't go below 0.
Oh,
But again, we're not accessing an array, we're accessing a map here, which shouldn't be able to hit a index. Hold on. And this is where I get into fun.
All right, then.
How did that go? No. Okay, so we have a problem where some of these are getting turned to null. Let's see what happened in my code down here where I'm setting. So fixed output, character I, character J, and then the value is getting nulled. Oh, that dumb. The parentheses in the wrong spot. I'm subtracting a number from the letter. So it's pulling the character C and I'm subtracting 1 from it because chars are numbers, it's valid. You can do addition and subtraction on characters because they are just represented as an integer, as a number. That's why the code was considered valid. But C minus 1 is capital C minus 1 is capital B. Capital T minus 1 is capital S. So it was valid issues. Good for me to actually show some of that. That's actually good to see. Yeah, good to remember that. That's why that was happening. There we go. I thought it was gonna work. Let me get rid of my system outs for a second. First off, that. Actually, for now, I'm gonna keep this code here so you can see it again. So first pass through, we have our A0TG1. We removed the G. See how that happened? We then removed a 5, a 4, a 3, 3. So this is the T. There it is. T. Then the A2 removed. Then we see we brought the G back. So again, what we expected happened. This was counted as valid. We then moved the G and put the G back. We then moved the, and since that was valid, we then brought the A back. That was invalid, so then we removed the A. And then we put the A back again when this was considered valid. So exactly what we said happened here is what happened in this as well. We did exactly what we said we did, and we got the results we wanted. So let me go ahead. So yeah, I removed that and run it again to make sure it doesn't show up. Good, no X mount. Let's submit it. And boom. So again, this one I specifically, this one's biggest issue was about going through logical deduction. And again, playing with it a lot and trying to introduce other concepts such as moving windows. I wanted to again show that 2D arrays are not the only system that can use two indices. That was another big item to show here, that you can use multiple indices to show multiple to keep track of multiple points in a system, especially when those systems have to be consecutive. And so for some of you, and again, I don't remember who exactly said some of these things, and again, I just want to see this in the video. Some of you again missed some of the things of just like we talked about consecutive, and for what Arnell mentioned about slowing down, make sure we're catching all those things. We want to make sure we do catch that concept of a substring is a subsequent made of 0 or more contiguous characters. So some of you may have missed that, and that's the idea of you're reading too fast or diving too fast into the code that we talked about with John. Same kind of concept there. Make sure you take that time to understand the problem, read the problem, and come up with a good plan of attack of testing. And I don't just mean coming up with a solution, but testing the concept, testing your understanding. Like I said, I had to test my understanding that I theoretically, based on these rules, could change the entire string. That was considered a valid option. And so that was just me testing my understanding and my logic and being like, can I work from this starting point? With this logical starting point, can I work something out with that? And so that's where I really like this problem, was that concept there, because I actually was looking forward to this example. So again, Thursday, starting early. I'm going to post that on Slack so those who weren't here today are aware of that we are starting early. Evan, I think you were the only one that actually raised your hand, so we'll work something out with you. Just let me know the earliest you can get in.
I just
what we'll
checked.
try to do is record it.
Looks like
Cool.
Evan got a haircut.
Awesome. I think you did, yeah. But yeah, I'm actually great to start that. I just every time I'm like, oh, we'll start at 6:30, everyone replied back with, I'm going to be late. I'm going to be late. I'm going to be late. So that's why I kept pushing it to 7. I kept trying to push class earlier, but everyone would say, oh, I'm going to be late then. Every time I'm like, oh, we'll start class at 6:30. Several of you guys reported. So I'm holding you all accountable. You all did this to me. You all said to Arnell, no, we can do 5:30. So I'm doing 5:30. All right.
Whoa, whoa, whoa! Don't let me in there. I didn't say I could do
You
5:30.
didn't say, but you didn't say you couldn't either.
I
Arnell
did.
called
You
it out
didn't hear me.
multiple times. Were you muted? Post something on Slack then, right away. Or
Okay.
cut them off then. What time can you do? The earliest.
Joel's not here either, but I don't know.
Mhm.
So I can.
I'm gonna be posting on Slack.
It depends if they don't have me, like if I'm not working extra to make a customer happy, but I can do 5:30. But that's why
Okay.
usually
Just
you
keep it
see me
posted then.
say, hey, I'm gonna be late.
Yep. Oh, no, I get that. I did the tech support stuff too. I knew when you got a call at the end of the day, you had to finish it.
Yeah. Well,
Just let us know.
It comes with every tech job. Sometimes they need something that day.
For me, it's more like my boss hit from California because he's 3 hours behind. Is like, hey, this company says they put in a ticket and nobody's looked at it and they're upset. Can you go ahead and look at it for me, please? You know what I mean? That type of stuff. But
Just let us
yeah,
know.
like
That's all you
if I
gotta do.
can't make it, I'll let you know if I can't make 5:30. You know what I mean? But
Okay, I'm gonna put it in Slack so that way it's on record. I'm gonna say that so far the only one we know of that mentioned an exception is Evan. So that way you can then put it in Slack. So that way it's on record. So if Arnell looks later, he can see it.
Okay.
So I want to make sure it's on record. So I'm gonna post in that only Evan mentioned an issue so that you have a chance to voice that issue. All right.
Okay, sounds good.
Cool.
But
right.
we should communicate if we're gonna run late, like an
Exactly.
issue comes up.
Yep, just let us know before class starts if you can. So before
Okay.
5:30, just let us know, hey, I'm running a little late. Here's when I'm expecting to be in. All right,
Okay.
All right, sounds good.
cool. I'll see everybody on Thursday.
I put the
Bye.
free code
I
camp
saw that.
open source on the GitHub. So if
Saw
anybody
that.
wants to
Appreciate
fool
it.
around with it, they can.
Cool. Thank you.
Yep.
I'll see everybody on Thursday. Good night.
Right.
Have a good night, guys.